Anyways, over to you, Gaurav.
Thanks, Carl. We have Harsh Thapar, who's the founder at Envirolizer. Hi, Harsh.
Hi, Gaurav. Hi, everybody. Delighted to be joining you all today.
Thanks. These jury members have had over 2 weeks to review your reports that you submitted. They have looked at your work in detail and have already assessed your entries for the 10 contest of the decathlon. Your presentation will help them hear your narrative. They will assess your presentation and your mastery over your solution through the Q&A session today. They will revise their scores based on the presentation that you give today and what they hear from you. So our first presentation is from Team Ecolution. They have worked on a Sacred Hearts secondary educational building in Kalyan. Their project partner is Sacred Heart CBSE School. Represented would be represented by the project partner. Moving if Before moving ahead, let's do a quick AV check with our presenters. Uh, I'll first go with Deep. Hi Deep, can you turn on your mic?
Hi, Gaurav.
Hi, thanks Deep. Hi Rashil.
Hi, Gaurav.
Hi Richa.
Hi, Gaurav.
Hi Shreya.
Hi, Gaurav.
I'll also ask Harshif to do a quick AV check with me.
Hi
Hi,
Gaurav, can you hear me?
thanks Harshif. I'll request the team to please go on the presentation mode. And
Is my screen visible? Hi, is
I
my
could
screen
see,
visible?
just a second. Yeah, go to the presentation mode, please.
Is it visible now?
Uh, do the entire screen as a screen share and not just as a window.
Yeah, that's
Okay, so I still can't see you going into the presentation mode. Could you just check that once?
all right. Stop sharing. 1 second. Is it in the presentation mode now?
Not yet. I could see your slides, but not in the presentation mode.
Now?
There's just still some issue. Are you trying with the when you are sharing the screen, do it as an entire screen. That
Yeah, okay, I'll do that. Is it visible now?
yeah, now it's visible. Yeah, thanks so much. So, team, you will have 25 minutes to present your work to the jury. At the 20th minute, I'll be ringing a signal, something like this. So that would be an indication that you are in the last 5 minutes of your presentation. Uh, You won't be getting any 26 minutes, so which means at the 25 minute, I'll have to ask you to stop you and end your presentations. After that, we will have 15 minutes of Q&A session. Please keep up your answers direct and to the point. So, okay, team, the stage is yours and all the best.
Thank you, Gaurav. Hello, everyone, and thank you for having us today. As said by Marianne Williamson, there is no single effort more radical in its potential for saving the world than the transformation of the way we raise our children. We, a driven group of students from Balwan Sheth School of Architecture, propound a holistic approach to the changing education scenario with a net zero and a resource efficient design. Through a thorough and pertinent solution finding route that we will be presenting today, we discuss the whys and the hows of our proposal. Our presentation today will broadly cover the site, the measures considered to produce a coherent design, and lastly, the relevance to the partner and the market. We partnered with the Sacred Heart School Kalyan, Mumbai, which is surrounded by an expanse of low-lying neighborhood, and the Radha Swami Satsang Vyas. The campus boasts of a student strength of 3,000 students and plans to add 300 more. It caters to a large rainwater management system, provides infrastructure for animal farming, and also for initiatives like waste collection. We decided that we'll nurture the site of 1,870 square meters, retain the 26 existing trees on site, as well as maintain the 1.8 meter contour on site. After understanding the site and the context, we looked at the pre-designed climate data to create a microclimate within our structure. Considering the warm and humid climate of Kalyan, we relied on employing passive strategies for 75 to 80% of our design, which significantly reduced the loads on our building. Post that, we came to the active strategies, which further helped us. We identified our goals and the project partner requisites as 5 major building blocks, starting with the collaborative learning, adding to enhance, where we build on the existing elements on site, inhabitable engagements, where we induce comfort and hospitality, grow your greens, and urban symbiotic farming initiative, and finally, emergent upcycling, where we upcycle and reduce material on site. As a key requirement for an educational building, we wanted to explore what really is learning, and we asked ourselves, how do we foster interaction between the students and the teachers for learning? How do we design to foster these kinds of interactions? And what if we broke down spaces in order to foster these kinds of interactions? So we came up with a system where we reformed the formal learning spaces with interactive elements and therefore allowed for collaborative learning. The next 10 contests establish how we've been able to achieve our goal.
So like Shreya mentioned, through the design, we clubbed the learning spaces with the interactive elements. We crafted 6 main concepts as learning moments, namely the engagement, the interaction, the flexibility, the modularity, the connection, as well as collaboration, which we inculcate in the building design at various scales. Through the form development, we considered major access and site conditions. The current site has an e-library which will be used by both the schools and is reallocated as part of a structure. The main mass of the school was fragmented into 2 major zones, the academic and the admin. The southern portion, as mentioned with respect to the climate data and the trees, was preferred for the academic function. The northern site, which then acts as an entrance to our site, houses the admin functions. The 2 zones are then bridged by the means of a courtyard. The diagram to the right further explains the programmatic zoning of our building. The detailing of the massing creates an engaging microcosm for the students. The journey of the school for the students is portrayed through the student spaces, the circulation spaces, as well as the social spaces in the building.
While resolving the architecture design, it was also important to account for the design's response to the risk through its ability to anticipate, absorb, and also adapt to the potential disruptive events that could come forward. Kalyan, faces the brunt of heavy flooding during monsoons, and with low-lying slum developments require effective evacuation and shelter arrangements. And Sacred Heart School is an established community shelter already, and we aim to expand its service by implementing resilient flood mitigation measures. So this further required the school to have a design that catered to the site conditions for water management and also provided a flexible yet responsive network for the community. A design that utilizes the terrain to reduce stormwater runoff and infiltration, and also has a good setup of green infrastructure to provide for the needs for the shelter and the school as well. So further, this habitable infrastructure through elevated plinth and roof system for solar fittings delivered a robust design with high risk performance. We propose durable and easy maintainable bamboo hinge windows for ventilation and daylight during these rainy days. Here, the life expectancy of the passively cooled design is managed by maintaining thermal heat gains, and the greens also spread across the whole design act as a sound buffer and provide a much more comfortable environment for the users on a daily basis. Looking forward to the classrooms, the school is designed with flexible spaces, allowing adaptability of use for both everyday expansions and disaster emergencies, as well as maximizing long-term utility of the facility. This arrangement helps in unprecedented situations like the pandemic as well. So, by also further developing a program of co-management of the microclimate for the staff and students and also the neighborhood, we promote a culture of care and respect for the physical infrastructure and thus also promote community resilience. And through initiatives like GYG, we strategically provide radiative cooling on the roof and also utilizes space through farming produce for innovative learning and also promoting self-sustenance for the school on the longer run.
The energy balance was brought about catering to the consumption demands through the generation. This was done by running some preliminary simulations on the building and setting our baseline EPI to 60. The three main strategies that we incorporated were the passive, the active, and the energy efficient construction, which helped us achieve a 24.3 EPI of the building. The strategies have been showcased through an instance of a class block. With respect to the climatic conditions, our main focus was to look at these passive strategies that are shown on the left, as well as the daylighting requirements to optimize the design for energy. To minimize air conditioning zones, we ensure that the courtyards and the passages are under minimal sunlight exposure for lower thermal temperatures. Use of LEDs, automation systems, as well as the VRV system for the air conditioning is done to further optimize the energy. Loads on the building were further reduced by keeping in mind the adaptive comfort ranges for the hot and humid climate in Kalyan. The animation on the left shows some instances of the air conditioning system set points, the automation, as well as the fenestration design, facilitating cross ventilation. We ran simulations with these parameters on Climate Studio to arrive at an EPI of 24.3. The main generation source on site is through the solar panels on the roof. Apart from the solar panel generation, the waste generated from the livestock, the food, the crops, and the wastewater is used to generate biogas, which can provide cooking gas to the Radha Swami Satsang. This chart summarizes the total energy balance on site. The total generation are more than the total consumption demands, showcasing the building as a net positive building. The consequence of adaptation is that the thermal comfort can be achieved in warm climates without air conditioning by using natural ventilation, solar shading, and intelligent building design. Designing is very crucial to create a comfortable environment for the end user. The radiation and the shadow analysis helped us exhibit that the proposed built mass shadows itself and constructs not just an open space for the social interaction, but also a comfortable temperature space. Since our site falls under hot and humid climate and the monsoon winds are prevalent from the southwest direction, the overall humidity levels are high. Facilitating cross ventilation through the structure allows lower humidity levels, in turn fostering a comfortable environment for the students, not only in the open spaces, but also in the most functional ones. the microclimatic conditions within the classroom spaces was important to understand the thermal comfort achieved in the interior spaces. Here, the instances of a classroom portrays the internal operative temperatures with the occupancy usage through different times of the year. The operative temperatures achieved within our space falls under the IMAC comfort standard ranges. Another comfort factor taken into consideration was the glare analysis. Maintaining thermal comfort within the internal learning spaces was extremely crucial. Consideration of the glare levels during the evening time when the sun exposure is towards the west is avoided, considering the operational school hour scheduling being under 8 a.m. to 3 p.m. Further, designing of the spaces with respect to acoustic comfort was something important for the learning perspective. Use of materials and natural sound barriers like the trees to cut off major sound disturbance into the space helps create a good acoustic environment. Taking into account reverberation times and conditions for echo, the material palette for the building was consciously chosen.
Coming to water performance, we've talked about cycling and reusing more than 25% of our on-site water. We also give back close to 35% of our water, hence making us a net water positive building. A typical school with a canteen would have an LPCD of 60 liters per person. However, in our case, we've divided our consumption into 31.4 liters per student and 47.3 liters per staff member, which is almost a net reduction of 50% from the base case. As a fundamental, the freshwater consumption demands are met by the rainwater harvesting system, specifically during the monsoon months. We also employ a monthly irrigation factor to optimally calculate the irrigation demands. The next few slides explain the strategies that have been employed by us, starting with using a range of fixtures for the washrooms and the HVAC system to reduce the net water demands. Further, we introduced floor surface finishes and native plant species with low evapotranspiration rates, which also helped us achieve a water balance. The circulation chart will show our design net water balance. After domestic consumption of the excess rainwater, it gets percolated into the ground. The grey water too, after being treated, is used for irrigation and flushing, and the rest gets percolated. Talking of percolation, we add 4 percolation pits on the site. We also add swales all around our structure, leading to the existing pond on site. Using these swales at appropriate distances allows for efficient drainage during the heavy monsoon periods. Finally, being a net water positive building, it was important to us to judiciously use the excess water on our site. The entire black water gets channeled into a biomass system. We use only 1/3 and 1/8 of our rainwater and the treated grey water. A fraction of the rest gets percolated into the groundwater, and the remaining is sold off to as construction water and potable water to the nearby areas.
To bring the vision of the project partner into reality, we also introduced and integrated multiple engineering systems into the design. We envision a quick construction process, one which is simple and efficient, catering to the project partner's demand. The column beam framework is constructed using RCC, which is also designed to cater to the loads for future expansion. The 1.8 meter raised structure enables for flood resilience, while the low U-value masonry of AAC blocks is used as an envelope. This construction process also aims to enforce local empowerment of laborers. All programs have different spatial requirements. For certain programs like the auditorium, the construction challenge is overcome by using a waffle slab system to facilitate a column-free space, while the acoustic performance is optimized by using red bricks. The mechanical ventilation in the structure is carried out by a VRV system, enabling individual units to be used as and when required. The system is zoned in 3 parts, catered by 3 outdoor units: the admin block, the academic block, and the auditorium block. For the student toilets, the technology of nanomembrane is employed, which is a low-cost, low-maintenance, no-flush system employing fecal biomass for its functioning. All the building service systems are also automated, including the VRV system, with smart device setups for maximum end-user involvement and reducing electricity loads. It also allows a requirement-based individual unit zoning for the HVAC system. Our approach to an innovative intervention also looped back to the initial idea of collaboration among the students. We wanted to explore the idea where student accountability is also inculcated in the daily operation of the school. So how could we introduce not just a student-student interaction, but also an interaction of the student with the school? Hence, we opted to pursue a traditional approach of ideation, bouncing off ideas, exploring, and even incorporating the workability and practicality of the design. These foundation ideas were carried forward by prototyping and testing, which also helped us maintain the feedback loop of resolving our designs. This methodology helped us come up with multiple innovative interventions, all of which were the byproduct of the individual space and its requirements. For example, the bamboo louvre primarily aids in maintaining the balance of light and heat for all classrooms facing south. On the other hand, the modular furniture is located at the primary entrance of the school, which is situated in the north. This helps regulate the spatial quality of the lecture hall, thus making it multifunctional and its usage changing according to the needs, like a display room or a workshop hall. Some of these interventions do have overlapping impacts. The bamboo frame is a modular intervention to regulate the privacy levels of the admin block. Yet one of its functions also allows it to act as an intermediate habitation space for butterfly and bird species that exist between the forest wall and the existing butterfly park on site. Apart from functionality, we also considered the possibility of a market relationship. Most of our designs possess the potential to be implemented elsewhere with similar climatic properties and requirements, and that too by simply assembling it on your own with a few steps.
We looked at the financial feasibility of our structure. To start with the total cost breakup of the hard cost, the soft cost, the 5% contingency cost, which all summed up to a total of 62.7 million rupees as our construction budget, which is roughly 17,600 rupees per square meters. We incur a net maintenance of minus 1.8 million rupees annually. Our materials cost of 29.7 million rupees, which largely includes the AAC blocks and the RCC. We also employ recycled and locally available materials like the corrugated sheets and the wooden sleepers, which make up the outdoor furniture, the planting trenches, as well as the landscaping screens. Additionally, we use bamboo for our shading devices and the PV truss system, which cumulatively we are able to save roughly 6 lakhs in the construction cost. The systems we employ incur a capex, they give us a revenue, and which is able to help us estimate the payback period. We consciously right-sized our solar PV and the HVAC systems to reduce this payback period. By utilizing the solar panels, we add a capex of 1.4 million rupees. However, by selling the electricity back to the grid, we save 2.3 lakhs rupees of every year. That brings the payback period to be just under 6 years. Coming to the cooling loads, we've swapped AAC blocks for bricks, and we've reduced the cooling loads by 20%, which leads to a savings of 3 lakh rupees in electricity every year. We were able to identify 2 sources of income. Firstly, the biogas plant, which costs 0.2 million rupees for construction and generates just enough energy to give us a revenue of 0.1 million rupees annually, which makes the payback period to be 2 years. With our water management systems, we induce a negligible capex. However, we are able to generate a revenue of 2.7 million rupees annually. With that, the payback period is just within the first year itself. This graph shows the cumulative life cycle cost of the base case and the design case. It suggests that we are spending 20% in the capex, which is an increase. However, the net maintenance comes to around minus 1.8 million rupees in the design case. Our life cycle cost thus goes under our initial capex and brings our total lifetime savings to 28 million rupees calculated over a period of 10 years.
As we know, marketing directly influences the profitability and the customer satisfaction. And because of that, the new extension of the school catered to the immediate surroundings and the neighborhood expands and with its initiatives and the proposed business setups. So the process of putting together the following market strategies involved inputs from all these stakeholders for cooperation within the user base as well. when we look at the construction technique, we understood the enrollment for the new session. It was planned to start from June and the building is to be completed by May. So this rapid construction reduced other construction costs such as idle labor on site, the rental cost of the equipment, etc. It also brings the project to the market sooner, which reduces the cost of capital for the developer. And hence, we approach the project in this phased manner and also provide a provision for the extension of the classrooms and the laboratories in the future for the school as need and requirements come. So, coming to the flexible school expansion, also along with that, we did propose business models for biogas and water, which make the school an active and contributory member of the neighborhood. These initiatives further add to the credibility of the sustainable image of the school, and it's a plan that best utilizes the design's resources and services to build the brand and also improve the market reach. Here also, the end users can evaluate how their lifestyle meshes with that of the school design through direct participation in these initiatives. The design targets creating flexible spaces which can accommodate the end user needs and the changing preferences, giving meaningful meanings to the community spaces for increased livability. These initiatives will further set an example for other schools to follow as for a much more expanded learning. To also, so now you would ask us how these discussed contests would result in a balanced proposal and why should you invest in this design? So while we follow simple steps to make a larger difference, we also impact beyond our site. While designing within the structure, we also go beyond it, whereby through harnessing the generation potential on site to its maximum, we produce more energy than the design consumes, and thus it helps saving the cost. So this net energy zero energy building can improve occupants' health, comfort, productivity, and whilst also providing the most efficient and economic design responses to the challenge. Also, through coupling of initiatives of GYG with innovative learning, we create increased demand because of better work-life balance and advanced amenities, and resonating with the ideologies of our target, thereby also drawing them into the Sacred Hearts brand network. This allows the school to reach out on a more personal level than the regular blanket marketing plans, and thus also fosters the USP of having lifelong relationships with the school itself. So finally, we can say that we understood architecture as a comprehensive subject that is collaborative effort of all the multiple industries that we did cater with. As through this project, we have gained a new admiration for the adjacent fields and their experts, and also have developed a deeper understanding for the social, educational, and environmental challenges that exist in the current scenario. Through breaking down these problems into smaller collaborative units, encouraging active learning, interactive relationships, and letting the building be a stage for education, we believe that the extension will be an example for the required pedagogical changes coming forward. It also represents an optimistic narrative for bridging sustainability and collective learning for the future generations of the school. Lastly, to put forward to something to think about, a quote by Christopher Falvin that says, building a world where we meet our own needs without denying the future generation a healthy society is not impossible, as some would assert. The question is where societies choose to put their creative efforts. Thank you.
That was a great presentation and you finished well within time. So thanks for that. Let's hear from the jury's comments and take questions from that.
Hi, Gaurav.
Hi.
Hi. So, do you want me to go first? Is that okay?
Yeah, you can go first.
Sure. I mean,
Yes.
firstly, I must congratulate. I mean, I really liked reading the report and the integrated kind of comprehensive approach. Right. I think it's running through the agenda, of the competition, that how to develop, a comprehensive look at high performance building. So I think you guys have done a lot of thinking. I think I want to start with some positives, and I think The positives are that you really made a lot of effort to look at different types of simulation, how they inform, your building decision making. You have actually played with them. I saw, use of CFD, which tends to be a more complex tool. I will not go into the accuracy of it, but at least at a start level, right? You try to play with it and develop an understanding. I was also very happy to see that you tried to answer some of the questions perhaps that might have reached my questions via the organizers. So that gives me a bit more insight into the architecture of it, which I was really missing in the report. Now, I want to, pose a question which has a couple of, sub questions. I'll let you answer, right? You have touched some of it. Now, looking at the climate that you mentioned, I was really looking forward to a bit more kind of detailed discussion on the climate. So I thought since it wasn't there, I will pose a question. So what I understand is it's a hot, humid climate, as you mentioned, and the main strategy for achieving passive comfort is actually naturally ventilating it. So I have a couple of questions with all the analysis that you did, including your CFD tools, and I saw some very interesting smoke visualization. So I want to hear more about that, and I want to hear about what decisions you reached about the depth of the classrooms, right? So I do see that you created windows on both the sides. What's the depth of the classrooms you achieved? And lastly, with everything that you did, right, to improve this passive performance, can you guess a number how much percentage of the occupied hours the building, your classrooms would operate, passively, right, and achieve comfort? Is there a broad number for it? So I'll leave you with that. I think it's really exciting.
So to answer your question for the climate data, we looked at a number of simulations wherein we had like a pre-designed climate analysis that we looked at. Then once we were at a designing stage, it was an iterative climate study that we did to arrive at a massing. And then the next step was to look at a post-design climate analysis, which is something that you saw as like within the CFD or with the smoke model or the daylight requirements that are there. To answer your question for the sizing of the classroom, so it's about 10 meters by 7 meter classroom, which in turn also was looked at in accordance to how the interaction of a student to a teacher would go about. So we even had an iterative process of how the classroom sizing would go about, and how the interaction would affect within that kind of space that's there. And even the two classes that are adjacent to each other have like a partition wall that's an openable wall for having like a combined kind of a session for the science students that are there.
Right. So just one thing, do you have a number for how much hours of your occupied period, it would run passively?
Yeah, so our school starts from about 8 o'clock, and according to our comfort kind of standards that we check, a 26 to 28 degree is something that is required for our kind of temperature range for the AC to work. So that kind of temperatures are somewhere around from 1 to 2, wherein it's towards the end of the school that's there. So majorly at the end 2 hours of the school is something that the AC requirement is there.
Okay. So you're saying only in the late afternoons. All right. Okay.
Yeah.
All right. I'll let the other jury react to it, and maybe we can, if you have time, we'll come back to it. But thank you very much.
Yeah, I'll go to Carl. Carl, if you have any questions.
Yeah, hi Gaurav, and hi Team Evolution. I hope I'm audible. I'm having a little bit of an internet.
Yeah, we can hear you, Carl.
Okay, so first and foremost, wonderful presentation, and like Harsh said, I think the way you all have sort of demonstrated the architectural design through a series of proper storyboarding is very visible in your presentation. So I'm glad that you all possibly took those comments on. I had very limited questions. When you look at, you say that you've raised your plinth by 1.8 meters. Is this a result of some high flood line or some flood mitigation study which was made available to you? How did you arrive at that sort of height? That's one question. Uh, what are the external finishes of the building that you've considered besides the windows? If you can just tell me about that. And have you thought of, or have you uh, been able to figure out this idea of using bamboo? Uh, how are you going to, the process of procurement to getting it to a level where it's usable? Can you shed some light on that? But I just have these 2 3 small questions.
To start with the plinth level, so even while we were dealing with resilience, because the school itself is a established community shelter that is working, so we took the plinth level from that also, and while doing the hydrodynamic study and the contour study, the contour is about 1.6 meters. So by raising that and using the hydrodynamic part of it, while the water is channeled through, it's not collected within the side but around it, like flows through around it. That is the way that we approach the 1.8 level, would be like significant and relevant for the design to have a much more flexible and better response to the flood problems that are there. And having swales around it will also cater to the and like the broken mass would cater to the resilient and flood mitigation measures that were taken into account. So that's how.
To add to that, we also did a QGIS drainage analysis for our site, which also helped us understand what kind of a water drainage system actually happens on site, like the natural drainage. And that also helped us deliberate on this 1.8 meter raised plinth. To answer your questions for the bamboo, Rushal would like to add a few things.
So for the bamboo, we had a discussion with our project partner as well. There's land available on the site where there is bamboo growing currently, but there's also space available where bamboo can be grown as well, and then that bamboo can also be used. Uh, Considering the procurement of bamboo, we approached a few dealers as well. So that was overall considered even in the affordability factor, considering the transport and stuff, etc., required for using bamboo to our site.
Again, to add to that, we talked to Conback, which is India's leading, and they have their plantations in Sindhudurg, which is not too far. However, the bamboo plantations on site aren't the optimum ones that we use for these kind of screens. So we are working with Conback in order to figure that out.
Thank you so much, team. We had the third jury member who was able to hear to your presentations, but due to some internet issues, he might have dropped off. So we won't hear the questions from his end. That was a beautiful presentation that you all did. So thank you, team. Now we'll have a 5 minutes break, jury members, and then we'll join back in 5 minutes with the second presentation.
Sorry to interrupt you, Gaurav. Sir asked us about the external finishes on our building. Wherever we're using AAC blocks, we do not rely on any kind of external finishing except for plaster and paint, because that's the most affordable solution while optimizing on the active strategies. And for the occupational hours that we were answering, a total of 5 hours in the 7 hour period that the students spend in the class, 5 hours are we are able to cater through passive strategies, and the remaining 2 hours maybe there's a need for the AC. That's all.
Thank you so much, team. Now you'll be taken into the backstage, and then you may leave the studio. Till then, jury members, we can have a 5 minutes of break. So thank you, everyone. Yeah.
Sure.
See,
Thank
Thank you very
you.
much.
Thank you.
Thank you.
We will start in about a minute.
Yes, sir. Yes.
Welcome back. Our next presentation is from Team 4. They have worked on a project Neeve in Raipur. The project partner is in Institute of Design Education and Architectural Studies in Nagpur. Uh, so I'll have a quick AV check with the team now. Hi, Khushi. Could
Hi,
you turn
sir.
on your mic? Hi.
Yeah.
Hi, Nathula.
Hello.
Hello. Hi, Shubham.
Hello. Hi.
Hello. Hi. I'll take Mansi also into the stream and do a quick AV check with her as well. Hi, Mansi. Could you turn on your video and audio, please?
Presentation
She would only run the slides.
Okay, no worries. Okay, fine.
Yeah.
Thank you, team. May I request you to now go to your presentation and into the presentation mode? I could see Mansi sharing the screen, but not her presentation. Yeah, I could see the presentation now. Could you go to the presentation mode? Yeah, perfect. Now I'm taking that to the stream. Yeah. So, team, you will have 25 minutes to present your work to the jury. At the 20 minutes, I would give you a ring like this. This will indicate that you have 5 minutes left for the presentation. You won't get the 26th minute, which means at 25 minutes, I'll have to stop you and end your presentation. After that, we'll have a 15 minutes of Q&A with the jury members. Please keep your answers direct and to the point. So with that, okay team, the stage is all yours, and I'll request you to start with your presentation. Let me just set the timer, and you can start with your presentation.
Yeah. So good afternoon, everyone. We are here to present to you Project Neeve, which is an educational institute proposed in Raipur. So to start with some facts and figures, we can see that the graphics show warming strips of temperature rise at global level in India and in Chhattisgarh, where the site is located. The data is with reference to the Institute of Environmental Analytics. The reason for temperature rise is lack of sustainability and adaptability, leading to imbalance of the earth ecosystem. This imbalance has led to climate change. Sustainable adaptation is essentially a global issue since social equity and environmental integrity are important for all populations in order to achieve sustainable responses to climate change. So, the approach for the project is to make a built form adaptable to the surrounding environment. Adaptability in nature can be observed in three forms: physiological, behavioral, and structural. At concept level, this adaptability in buildings is interpreted where physiological is the understanding of activity and function. Behavioral talks about interaction with the surrounding to reduce its impact, and structural is about the building envelope for user thermal comfort. The interaction of building with the surrounding can be seen in two aspects. One is the presence of building related to embodied energy, and second is a reduction in the operational energy. This concept was thought to be addressed through the requirements of the competition, that is typology, requirement of project partner, and the contest areas. So, why we chose an educational building? Students are the future generations of the planet. Moreover, students of an architecture institute can be tapped and molded as potential change makers. By studying in an institute that contributes to the environment and sustainability, a mindset thus can be developed. Design of an educational building can instigate the thoughts and perspectives of students, thus preparing them to combat future climate change. The graphs are about current scenario of energy use and CO2 emissions, which shows that maximum energy consumption in educational building is due to lighting and space cooling. The challenge is to reduce energy consumption during the operational phase through efficient building design. Project Neeve is an architecture and design institute located in the outskirts of Raipur. The courses offered are B-Arch, B-Design with a total intake of 80 students and 40 students respectively. The building has been proposed for a total of 840 users, including students, faculties, and support staff. Spaces like studios, AV rooms, administration, library, auditorium, staff rooms, etc., form the building program of this kind of an institute. The proposal has been designed addressing to the 9 contest areas with respect to the competition brief. These are the 9 contest areas: energy performance, water performance, resilience, affordability, scalability and market potential, comfort and environmental quality, architectural design, innovation, and engineering design and operations. So, to start with the site level, the first step was to understand the natural resources, that is, sun, wind, rain, and rain. The site receives summer and winter sun and can be seen in the slide. It receives monsoon winds from the southwest, summer winds from the northwest, and the winter winds from the northeast direction. The available resources on site are site geometry, site slope, soil condition, water table, and context. The site has a total area of 8,000 meters square approximately, and it is 25 kilometers away from the main city. Raipur falls under composite climate zone, and the climate analysis was performed with the help of bioclimatic chart, which gives a major challenge to address the extreme conditions during summers and winters. For both the seasons, the design needs to address thermal comfort range during monsoon. The humidity is high, which also has to be addressed with appropriate ventilation strategies. The proposal needs to address to the comfort requirement range, that is 22 to 28 degrees Celsius, with respect to the adaptive thermal comfort model. The orientation of the site is such that the longer axis is along east-west direction, hence beneficial in reduction of the heat gain of the mass. The activities are divided into 3 modes of operation, that is air-conditioned, naturally ventilated, and mixed mode. The zoning of activities is based on the function as well as the thermal comfort requirement of each mode of operation to reduce the energy consumption demands. For example, auditorium, which is an air-conditioned space, is located towards the north direction to reduce the heat gain, in turn reducing the cooling load and energy consumption. The diagram also has spaces where common activities such as OET, library, and auditorium are planned to connect as well as to separate the front zone of B-Arch and the rear zone of B-Design. As mentioned earlier, the orientation provides benefits in terms of reduction in heat gain. Open pockets are planned for venturi effect, sunshade, and cross ventilation to provide thermal comfort in all seasons. Massing modulation create terraces for incorporating informal spaces. Service block is incorporated and activities are planned with respect to the courtyards and OET. 3 major open pockets are summer courtyard, winter courtyard, and the open air theatre. The design and performance of these open pockets in different seasons will be discussed in the building level strategies. Rainwater harvesting has been proposed, where the water is collected as surface runoff from terraces and hardscapes, and the groundwater is recharged through the landscaped areas. The location of tanks can be seen in the diagrams. The total annual rainwater that is harvested comes to be approximately 56 lakhs liters of rainwater. The landscape spaces have been designed for optimizing daylight and ventilation and to provide informal spaces for recreational activities. The orientation, configuration, and proposed shading devices have also been considered while designing the landscape of the open areas. These are the detailed landscape design plans where you can see the character of the open space, which intends to enhance the interaction, provide recreation along with thermal comfort. Also, use of native plants and trees and adopting xeriscaping technique for landscape design reduce the water demand significantly. The plant species used for designing landscape can be seen. A thoughtful provision of grass area and strategically designing softscape and hardscape surfaces has been done. The open pockets provide perforations for night cooling, and appropriate landscape treatment help to reduce the UHI effect in future. The site plan has been designed keeping in mind the accessibility and foreground for visual appreciation and parking facilities. It also shows the open build configuration and the terrace areas. The solar panels have been used and designed to be located at the terrace level. Because here we are discussing about the Institute of Architecture and Design, the build form must be such that it provides an experiential journey and enhances that creative instinct into the students. Therefore, this particular journey map shows major important locations of the institute that enhances the quality of experience of the building. So to start with the foreground provides opportunity for visual appreciation of the building form. The entrance has volume modulations and landscape areas. The space is intended to make it interactive for discussions and visual connectivity. Near the front courtyard, an overlooking single flight staircase is encountered and the stack effect is experienced where the winds flow from the courtyard to the double heighted puncture. The front courtyard is winter courtyard which allows sunlight and acts as a spillover space for discussions and informal activities. The OAT has overlooking balconies and shading devices, and the space will be used for events and recreational activities. The rear courtyard has an overlooking staircase block to make the space interactive and keep the block lit. It also has seating spaces for discussions. The studio spaces with fins allow diffused light and creates shading patterns giving different experiences at different times of the day. The exploded view shows spatial arrangement of activities at different floor levels. The views on the left show the character of spaces like courtyards and the overall built form. The volumetric modulation enhances the visual connectivity within the built form as can be seen in the section. The configuration of the overhead shading device creates shading patterns and makes the overall space interesting. The architectural character has been designed to integrate the local elements, hence giving it a modern yet an earthy appearance.
To start with building level strategies, the strategies are material specification, shading device, one room deep concept, thermal comfort, Venturi effect, and stack effect. Shading mask and downdraft system are also the strategies incorporated at building level. The prime objectives of building level strategies is to bring thermal comfort to naturally ventilated, mixed mode, and air conditioned spaces. Material selection and fins are provided for naturally ventilated spaces. Kinetic facade is used for mixed mode spaces, and jali with deciduous vegetation is used for air conditioned spaces on north facade. The first two strategies are material specification and shading devices, which are part of envelope design. The objective for selection of an envelope material were to minimize the heat transfer from wall, roof, and window. The material should be cost effective and have low embodied energy. It was ensured that the material is selected within 30-kilometer radius after market survey. Materials were compared and selected on the basis of U value and cooling load through simulations. The chart shows the selected material sets for wall, roof, and glazing after optimizing for various factors like cooling load, cost, and availability. Coming to shading devices, it includes slanted vertical fins and daylighting shelves. These strategies are used to reduce heat gain and enhance the daylighting conditions. Vertical slanted fins were strategically designed considering solar azimuth angle to reduce direct heat gain and obstruct summer winds from northwest. The angular placement of fins towards southwest allows winter sun and monsoon wind. These are the construction details for slanted vertical fins. The shadow pattern shows difference in summer and winter, and the table shows 26% reduction in the heat gain, which is achieved with the use of materials and vertical slanted louvers when simulated in Design Builder. This would help to achieve indoor thermal comfort range in naturally ventilated spaces. These clips show how combination of vertical slanted louvers and daylighting shelves cast shadow on the facade during summers by cutting higher angle sun and allows penetration of lower angle winter sun. The first clip is about for the summers from February to June, and the second one is for winters from October to January. The second strategy under envelope design is daylighting shelves, which increases the daylighting penetration into the studio spaces by reflecting it through ceiling as shown in figure. Conventional openings with WWR 45% provided good daylighting but caused glare near openings along with the heat gain. Though introduction of vertical fins vertical fins reduced heat gain, it also reduced daylighting penetration. Hence, daylighting shelves were provided, which optimized heat gain as well as penetration of daylight. Daylighting simulations were performed on Light Stanza software. One room deep concept was adapted in planning. It allows sunlight to enter into the studio spaces through courtyards and exterior facades. It increases the visual connectivity and make the build form porous. Open spaces can act as direct spillover spaces for informal activities and interaction from spaces like auditorium and cafeteria. It helps in cross ventilation to reduce the humidity. Open spaces are designed as microclimate regulators for thermal comfort in all the seasons. The south-facing courtyard and OAT are designed with jali walls, which creates venturi effect and allows wind throughout the monsoon. The wind from OAT enters courtyard 2, creating upward draft to remove heat through stack effect. This is a section through open air theater and corridor depicting venturi effect through opening beside auditorium during monsoon. The second section is cut through front courtyard and double height foyer with roof opening. Wind entering from courtyard escapes from foyer opening, creating stack effect. Open air theater acts as a spillover space for informal activities. The shading device is designed to obstruct summer sun and allow winter sun to ensure thermal comfort in both the seasons. The slanted shading devices also enhances the visual experience during monsoon season. Shading mask has been designed for the OAT using Andrew Marsh tool. The diagram shows shading during summer months and penetration of sun during winters. We can see the difference in shading during winter and summer. Along with venturi effect and stack effect explained before, the downdraft system is used to enhance the thermal comfort in naturally ventilated studios by balancing the heat gain. Calculations for the downdraft system were referred from book Sun, Wind and Light by G.Z. Brown and Mark Dickey.
These are the other strategies which are incorporated to enhance the overall performance of the building in all contest areas. Moving on to 6 other strategies, it includes kinetic facade, efficient electrical appliances, radiant cooling system, solar pave system, water management system, and sewage treatment plant. The major objective of the kinetic facade is to optimize the heat gain and daylight in the mixed mode spaces on west and south facade. The innovation is a double skin which can change its function, feature, behavior over time to improve the overall building performance to achieve the maximum efficiency. The main feature in the facade is thermal comfort, daylighting, optimization, and its appearance. This facade system decreases the heat gain and glare by adapting itself in a different angle and orientation. This elevation shows how the kinetic facade works and looks. Each module can change its opening responding to the intensity of radiation with the help of sensor and reducing the heat gain. Changing facade in a different season gives us a different appearance at a different time. These two pictures shows the simulation of a heat gains in a fins and kinetic facade. It can be observed that the heat gain is reduced with the kinetic facade. The kinetic facade is made up of 516 individual panels which are controlled via the building management system. Each unit has a four fiber reinforcement panels and driven by a rotary motor. The system is linked by sensors that will change the angles of panels as per the solar radiation sensed by the pyranometer. Usually this system has a complex mechanism, but in the proposed kinetic facade, the joineries are designed to minimize the complexities and maintenance. Material specification has been detailed out and the costing has been calculated to make the proposal practical and applicable. Since the kinetic facade is made up of translucent FRP panel, it allows a diffuse light even in 0% of opening. Kinetic facade has a product target and can cater to the many building typologies such as institutional, commercial, residential, health and facilities, and industrials, etc. The dimensions of a single module of a kinetic facade are repetitive in the nature and allows a multiple module to set as per the size of the facade. The module allows its use for allowance and restriction for the solar radiation, wind, and daylight. Kinetic facade is easy to develop for a manufacturer due to its flexibility in terms of selections of a material and simple manufacturing details. This module can also be used as a static facade in case of requirement of a Venturi effect as demonstrated in the screen of courtyards of a proposed building. The proposed building itself becomes a display of a workability of a kinetic facade to reach out the public and end users to increase its market potential. We try to use the efficient artificial lighting equipment to achieve the LPT with the range of ASHRAE standards. All daylight techniques that are used as effectively reduce the energy consumption required for the artificial lighting. The graph shows the comparison of a conventional with efficient electrical appliances. It reduces the energy demand by 14% annually and would be beneficial in terms of cost saving in future. For conditioned spaces, we use the cooling system with dedicated outdoor unit. It provides a benefit in terms of energy consumption, cost, and maintenance. This system differs in the distribution system as compared to the conventional system. Radiant panel consists of menders which can be fixed in two ways, either directly in floors or suspended with plasterboard ceiling. Fixing with plasterboard ceiling has been used in the proposal as shown. The fixing of the system with plasterboards give a benefit of a reduction in maintenance cost by 60%. In the radiant cooling system, the sensible heat is absorbed by cooling coil due to which total tonnage has been reduced by 23%. Energy is saved annually. The graph shows the annual energy comparison of a different element of a radiant cooling system and conventional system. In the radiant cooling system, we have 10% of total cost as compared to the conventional. This is due to reduced demand of a cool fresh air, which eliminates the use of AHU and water demand along with ducting. This graph shows the cost comparison in terms of energy between the two systems. We can infer that there is a 25.6% of reduction in 10 years, which proved to be a cost effective. A 250 kilowatt on-grid roof-mounted PV system has been installed on the terrace, which generates 3,65,000 kilowatt annually, and it's greater than the total energy demand of a building, hence make it net positive. We have used the monocrystalline solar panels which are made out of pure high-quality silicon. The efficiency of a level, this panel is 19 to 20% and require a less space than polycrystalline solar panels. Site plan shows the location of a solar panels on the rooftop. The solar generation system is compared with the conventional energy system, and it can be seen that the solar generation system requires a high initial investment, but the total cost is recovered over a period of time. The water cycle diagram shows the source, treatment, and circulation of water with a specified volume. The rainwater is collected, which is filtered and stored in the underground tanks. The treated water is pumped to the overhead tank for flushing and other purposes. The generated grey water is treated and reused for irrigation and flushing. The table shows the capacity of a different overhead and underground tanks. The use of low fixtures in the proposal has reduced the water demand by 55%. According to the NBC, the water demand for flushing is 20 liters, but by the using of this fixture, the demand is reduced to 10 liters per person, thus reducing overall demand from 45 liters to 35 liters per person daily. This table shows all fixtures in terms of sizing, cost, and manufacture, etc. The diagram shows the circulation of water on site with STP, storage tanks, treatment, inspection chambers, and toilet. The detailed toilet layout has been shown. The graph shows the comparison of a total water demand harvested, rainwater, and grey water generation. After detailed calculation, we infer that the proposal is a net zero water design. The sewage treatment plant is designed to treat 40,000 liters of sewage generated per day. It is an MSEB fabricated based plant, and details are shown in the table.
So after understanding the entire proposal, we can lead to have a glance of all the contest areas and performance of the building. This slide shows identification of contest areas which are covered through different strategies at all the three levels, that is site level, building level, and other strategies. So this is the list of all the strategies that were incorporated and proposed under each contest area. While design evolution, it was observed that any particular strategy contributed to enhance performance of more than one contest area, which we made a matrix as can be seen in the slide. So, thus, the contest areas are interrelated and the intensity of interrelationship of each contest area was developed and made a matrix, as can be seen. These are the performance specifications of the proposal for envelope, HVAC, lighting, electrical, renewable energy, and water systems, and STP. So to sum up the entire proposal, the achieved API was 41 kilowatt hour per square meter per year, and EUI achieved was 12.90 kBTU per square feet per year. We were able to achieve a net zero water energy design with different design strategies and the innovation of kinetic facade, hence addressing the challenge of future climate change. When the cost of conventional and proposed building is compared, it is observed that the proposed building asks for a higher initial investment, but over a period of 10 years, it is proved to be affordable. So, as students of architecture, we have taken a step to be the change and to get closer to net zero. I would like to thank the Institute, faculty lead, advisors, and the entire team for their consistent efforts throughout the competition. Thank you so much.
Thank you so much, team. You finished well within time, so appreciate that. Great presentation. Now we'll take the jury comments. Go to I'll go to Harsh first.
Okay. Yeah, thanks, Saurav, and thanks, team, for I think a great effort. I think I really admire how you guys have put together very different kind of integrated thinking, different kind of analysis, into a comprehensive process. So I must congratulate you that this competition has given you and all of us, kind of with you, a very good perspective on how kind of high performance buildings, net zero buildings really come together, right? So from that perspective, that I like the integrated approach. I would pick up just bits and pieces of it. So look at my comments as something which is in a way a little bit nitpicking, but I think it's important that essentially we discuss those points. So again, I'll start with some positives. I think I detected some very good thinking and clear thinking about the external microclimatic strategy, right? So what I notice is that the building actually sits on next to a highway, and essentially it is quite exposed and essentially agricultural land all around. So I think that the fact that you mentioned a summer courtyard and a winter courtyard, I think is a progress, right? Because I think one of the principles we need to really always remember with external spaces is that the sun moves, the wind moves. We are not essentially able to control them all the time, but we're able to study them and we're able to identify the spaces that work better than this. So that's great. Now the question there I have is, when I look at the images of the roof view or the site plan that you showed, I detect a lot of building mass and very less green areas. I think so. That's my question. Did you have an opportunity to put less building mass, and kind of leave more of the land actually open? That was my question. And the second, another related aspect that I wanted to ask you about is that you mentioned, you showed certain explorations in shading and leading to kinetic facade, right? So excellent. I think a lot of exploration on that. My question there is that what is the metric, in terms of daylight analysis? I saw lux levels, right? Average lux levels taken from NBC. My question there is, what is the best metric that you could have used, right? Maybe an annual metric, right? Like a daylight autonomy or SDA or something like that. If you can explain a little bit more on that. So two questions. Too much building on the site. Could you have gone with less? I also don't see space for parking. I imagine there is no basement parking in it, right? So there is a lot of kind of congestion that I see. And second is daylight metrics. What have you used, and is there anything other that we could have done?
Um, so talking about the like the building mass, I think it was challenge for us also to incorporate such like a large area program in the site. And the second about the parking, sir, we have provided basement under the building, so taking care of all parking,
Okay,
uh,
sure.
except for bus and visitors.
Okay, the second bit then. What is the daylight metric you're using for your analysis, and why?
Sir, we analyzed our daylighting conditions using lux levels, like for the penetration of the um, sunlight into the studios. So our
Okay,
goal
so
wasn't about the annual daylighting; it was to achieve the highest level of penetration into the studios, like maximum distance should be covered. So that's why we introduced daylighting shells.
Uh,
okay, okay.
Thanks. Okay, thanks. May I move to Carl?
Hi, Team Fob. Nice presentation. My questions are very similar to Harsh's actually. Um, you have an area program for 840, 50 users, including students, faculty of it. But the built up area appears to be disproportionately high. So my question is, I'm sorry, I may not have picked it in your presentation and I've forgotten because I've seen your report a few days ago. What is the area of the building, the total built-up area of the building versus the total carpet or the total usable area? I asked this question not to sort of get figures and facts out of you, but rather, the first and foremost uh, thing about being sustainable is to build only as much as you require. And uh, we've we used to, this is just some experience I'm sharing with you. Usable to non-usable spaces in educational buildings used to be 1:4, 1:5, which have over the last 10 years become 1:2, and now they're down to 1:6, 1:1.6, 1.7, and you still get very energy and very comfort driven buildings. So what is that area is one question. A small technical point, I did not see any indication of a basement. Your colleague clarified there is a basement. And the last point is, you put the kinetic facade in a location where you have AV studios behind it. So that didn't actually add up. Whether you could have chosen a better location for it, or did you choose that location because you did not want to have a kinetic facade behind a hardcore teaching space? Could be an answer, but if you can clarify that. And since you've gone all the way of doing a kinetic facade, why not just do the entire building in a kinetic facade? What stopped you from doing that? Over to you guys.
So talking about the area program was very exhaustive, and we had to incorporate BRs and we designed both the batches. And also we have tried to incorporate common spaces. So for the activities like computer labs and staff rooms, we have incorporated both the designs, both the streams, and had common spaces to reduce on the space configuration. And talking about the massing, the intention was to provide interactive spaces, informal spaces, spaces for sports and activities, because for students of architecture and design, we require certain instinct to sort of survive architecture and design. So these kind of spaces, we thought that we need to incorporate so that there's a interactive and a very nice learning environment in the entire built form.
Um,
Talking about the placement of kinetic facade, we deliberately did it on the facades of AV rooms and mixed mode spaces. So that was deliberately done, and we avoided it in the studio spaces or the workshop spaces, like where architecture students mostly work, because of the we use their naturally ventilated spaces, and fins were used on the on those facades.
Thank you. May I ask Isaac to have his comments or any questions?
Yeah, so thank you, Kushi, Nathulal, and Shubham. It was a very nice presentation, and I hope you have begun a new journey, in the through the Solar Decathlon, for the rest of your life. Yeah, the word kinetic facade keeps coming again and again. I think all three of us have been caught up by it. I just want to stretch a little bit of your imagination towards end of life. Yeah, did you ever think about what will happen at the end of the life of the kinetic facades? You mentioned that it's made up of FRP. Yeah, and what is the duration of it? How long does it last? And then at the end of life, what happens to it? Because you also mentioned about some recycling initiatives which you take, in your presentation. So there is a tendency towards the circular economy, which is coming actually into the game. Did you ever put some thoughts into that?
So the kinetic facade has basically a framework and the individual module units. So the framework is designed in such a way that it is really simple and doesn't have many complex mechanisms. So the framework could be reused in the future years if we want to replace it or whatever. So the also answering the question to Carl sir, that why not the whole building is kinetic facade. So here the question comes regarding affordability. Just because we have a kinetic facade, we cannot put it on the entire building because it is optimized only for the mixed mode use spaces. So for mixed mode use spaces, it is mixed mode because sometimes it would be air conditioned, sometimes it would be naturally ventilated. So the kinetic facade is optimized according to that, and only in those certain pockets and composition we have put the kinetic facade.
Thank you. We are also being joined by your project partner, Professor Abhay. So I think he might have joined a bit late, but I'd like to ask Professor Abhay to have some concluding remarks for your team. I hope you are able to look at their work. So, any concluding remarks before we break out for the lunch?
Thanks, Gaurav sir. Basically, when this entire project, started as such, we were sort of, we were in a dual mind, saying that, okay, are they going to be capable of, meeting the professional challenge of giving a building, which is institutional building, which is actually suitable for the climatic considerations of Raipur, because this is a live project. So, and we all are architects. I mean, we are running the School of Architecture. And when these guys and the fourth year students, they started working on it, and I started seeing the progress as such. I'm telling you, I'm impressed. I mean, I'm not impressed basically because of their work. Their work is, yes, their work is a very good thing to happen. But at the same point of time, the way the competition has been conducted, no, it is fantastic. So they have got a lot of opportunities to go through it. Not only they, we as the faculty members, we as the architects who have been joined with that as such also have learned quite a lot of things. And so this is going to change, I'm telling you, this is going to change the way we are looking at the buildings forever, for all of us. We are very happy that they have come to a level. I don't know, this is a competition. They may win, they may not win. Whatever way it happens, it happens. But what happens is that we are convinced that they have taken adequate labor. They have come up with the innovative concepts, the courtyards, the interplay of the solids and voids, all is, and even integrating the building materials which are available in the vicinity of the site. So they have they have done, I mean, they have not kept any stone unturned to come to the conclusion. This is what I wanted to share with you. This I didn't share with them, in fact, instantly. So I'm sharing it from this platform. Thank you very much for giving me the opportunity. Thanks a lot.
Thank you so much, sir. It would be a win situation if it gets built, so that would be the much bigger prize for the team. So I hope that happens. So
Yeah.
thank you so much for the time and well done, team. You did a good job. Now we'll break out for a longer break. We'll have a lunch break for next hour. Jury members, we will join back at 1:40 p.m. and we'll have the third presentation after that. So thank you, everyone, and
Thank you, everyone.
thank
Thank
you.
you.
Good.
Thank you. Thank you so much.
Welcome back, everyone. We would start the session in another couple of minutes. Uh, Hope the team Arkons have joined back. So we'll start in a couple of minutes.
Hi Gaurav, I've joined from another device. Am I audible? I just want to check.
Yes, you're audible.
Gaurav?
Thank you.
Yeah, sorry, I wasn't mute. Hi Isaac, hi Carl, I can hear you. Yeah, thanks Sachi. We will start with the presentations. Harsh might join soon. Uh, so hello everyone, welcome back to the Educational Building Division. We will continue with our presentations. Uh, our third presentation is from the team Arkons. They have worked on the ORD International School in Noida. Their project partners is ORD Towers. Uh, I would quickly take the members into the stream. Uh, so, hello team, we will quickly have a AV check. So I'll start with Aman. Hi Aman.
Yeah, hello Gaurav. Hi, how are you?
Thanks. Uh, Hi Sheen.
Hello, sir.
Hi. Hi Pratyush.
Hello, sir.
And hi Dakshil.
Hello, guys.
I'll request the team to start sharing your screen now and into the presentation. There's some disturbance at your end, Dakshil. So thank you. And you may isolate and set in some isolated place. That would be helpful. Go to the present. I could see your screen, but go to the presentation mode. Okay, thanks. So team, you will have 25 minutes to present your work. At the 28th minute, I would ring a signal like this. You won't have the 26th minute, so please stick to the timelines, which means at 25 minutes, I'll have to stop you and ask you to end your presentation. After that, we will have 15 minutes of Q&A with the jury members. Please keep your answers direct and to the point. Your project partner will provide some comments during the if project partners join in, he might provide some comments at the end of this session as well. Okay, team, the stage is all yours. All the best, and you may start with your presentations now.
Hello and good afternoon, everyone. We present to you ORD International School, our net zero energy and water educational building project. We, the team Arkons, comprise 12 members from third year Bachelor of Architecture and one member from second year Masters of BEM from School of Planning and Architecture, New Delhi. Our team is advised by our faculty, Professor Dr. Shweta Manchanda. Here, I, Pratyush Anand,
Myself, Aman Raj.
Myself, Dakshil Rana.
And I, Sheen Parimu.
we'll talk in detail about our project. Through this project, we set out to explore how educating children can help in mitigating climate change.
The concept of sustainability has been present for the last 30 years, yet we've been seeing a steady increase in greenhouse gas emissions, to which buildings are the largest contributors. Buildings are around for decades, so the impact that they have on their surroundings really matters. They affect the communities around them, they affect the economy, and they impact the environment. So, designing a school is like shaping the thoughts of the younger generation. So, we planned not just as architects but also as educators. We envisaged a building that would change the way children are taught about sustainability, a building that would become a concrete part of the curriculum to educate students and communities over many years of change.
ORD International School is an IB affiliated educational building located on a site area of 3.7 acres with an occupancy of 2,400 students. It is designed for our project partner ORD Towers, complying with Noida bylaws. The site is located in Sector 134 of Noida, Uttar Pradesh, within the development area of JP Wishtown. The surrounding area is a majorly residential sector. This being said, we started developing concepts for our school building, which will see an influx of students from different communities and nationalities. The school is being designed to cater to the mixed diversity of people living in the locality of the sector. Being developed in stages, the area holds multinational offices with high-class occupants. The wish town is scattered across 4 nearby sectors, and this is a site provided for an educational building. The front face of the site is in the northwest direction with the winds flowing in the north and northeast. Lying in the composite zone, the climate of Noida provides challenges for comfort and water criteria. The temperature in Noida ranges from 7 degree to 44 degrees Celsius, which is a cooling dominant area.
Building a sustainable school is not just about saving energy, we also focused on the quality of the learning environment. We have designed our building around principles like biophilia, holistic design, safety and security, passive strategies, and modularity. The school's design is driven by daylight and solar radiation. The entire building is oriented along the north-south axis with narrow floor plates to capture the greatest amount of sunlight throughout the day. The building is then stepped down towards the south to bring in the low-angled winter sun. Courtyard spaces are incorporated in between to bring in additional light and create a cool microclimate. The team then considered how to organize the school's various functions and started by placing classrooms and other academic spaces along the north and south. Services, toilets, and other activities are placed on the east and west faces of the building. The school campus incorporates facilities like an academic block, a multipurpose sports block, canteen, futsal field, and a playground. The site has 3 separate entrances for buses, pedestrians, and cars. We have provided 15 parking spaces for buses. These buses enter directly into the bus park where the boarding and deboarding happens. The bus stand is constructed entirely of 100% permeable pavers filled with gravel, and it does not add to the hardscape.
The car entry is only for staff and the ramp at number 8 leads them into the basement parking. Then we have a pedestrian and bicycle entry with a cycle stand at number 3. The path from there leads people into the main building. The building blocks are surrounded by a 6-meter wide fire tender path which is paved with 100% recycled permeable pavers. Inside the building, spaces are divided to segregate students of different age groups into 3 different blocks with multiple stories. Older students have their classrooms and activities on the upper floors. Younger students have their daily activities on lower floors for ease of access. Like here on the ground floor plan, Pre-primary students have their classrooms at number 6 very close to the entrance and the separate playground in the north courtyard at number 13, which has natural surveillance from all directions, making it a safe space for younger students. The middle block comprises primary classrooms with easy accessibility second to pre-primary blocks. These students have all their activity rooms and studios in the southern block across the courtyard, which serves as a playground for their age group.
The furniture layouts of the classrooms and laboratories are designed considering factors like position of windows and the associated daylight distribution. It impacts hugely to make spaces glare-free and comfortable. All the interior materials and finishes used are VOC-free and provide good acoustic insulation to make the classrooms noise-free. We have designed cardboard furniture for an unconventional classroom experience. Interactive partition walls are placed in between pre-primary classes. It helps the classroom to develop as a play area, increasing students' physical activity. These elements would repurpose all the waste cardboard from the packaging of all equipments and fixtures assimilated in the school. If making a net positive building seems far-fetched, a school in Noida presents an especially tough challenge with the city's density. It makes it difficult to find a site with sufficient roof space or an unshaded and rightly oriented area to mount PV panels. We designed a school with vastly reduced energy consumption to meet all its energy needs in this dense urban setting. Due to the limited amount of power that could be economically generated on the site, the project's most effective energy-saving features are based on passive design strategies like wind towers, highly insulated building envelope, and well-designed shading devices. The external walls are clad with terracotta tiles, which have good thermal and acoustic insulation properties. It reduces the surface temperature of walls. It is 100% natural, recyclable, durable, and it requires no maintenance. We have integrated the plants into the facade at the window level. It helps simulate an association with outdoors and help with students' mental and psychological well-being.
Radiation being the major source of heat gain through the envelope, using optimum window-wall ratio, efficient sunshades, and mutual shading through buildings, we created low radiation blue pockets on the southern wall. Being comfortable is a basic requirement and not a luxury for anyone inside or outside the building, but it is often thought only in terms of maintaining optimum temperature in the immediate surrounding. Hence, in our design, we have taken due care in maintaining optimum lighting levels as defined by ECBC inside the working spaces. Three-step lighting sensors with average 67% SDA reduces lighting energy consumption by 80%. It also maintains a happy and productive learning environment. Buildings can achieve required set points very easily, but at the cost of high energy consumption. Hence, we analyze the operational hours through the year by superimposing the temperature outputs from wind tower with the IMAC mixed mode model and found out that 77.8% of hours lie in the comfort band without any use of refrigerant cooling. This model recognizes the adaptability of human body with changing climatic conditions throughout the year.
We have also focused on microclimate on our site by incorporating courtyards for adaptive transition between spaces and hence reducing the building's climatic stress. Planters are also incorporated throughout the facade to absorb sound coming from the outside traffic, along with the use of terracotta on the external facade, which acts as sound insulation. Yet another challenge was to enhance the indoor air quality, keeping in mind the pollution levels of the regions and the contaminants released by the occupants. We analyzed the fresh air requirements and adopted the displacement ventilation method, ensuring that fresh air is adequately maintained at all times. This method supplies the air at a lower level and comes in contact with the occupants. As it becomes hotter, it takes all the contaminant particles along with it and accumulates at the top layer in the zone. It is then extracted out by return air ducts placed at the ceiling level. This system not only conditions the occupied zone but also prevents the pollutant particles from mixing with the supplied fresh air, hence eliminating the need for ceiling fans. Cooling energy alone counts for around 55% of our total building energy. Hence, HVAC is one of the complex systems to integrate into our building. To bring down this cooling energy by 57%, wind towers incorporated with VRF systems are being proposed. Wind towers work on the principle of downdraft evaporative cooling. It stores the cooling effect due to evaporation in the thermal mass during the night, and passing the air during the daytime, the air loses heat and reduces its temperature. It is then circulated to classrooms through air handling units placed at each floor level after treating for humidity and other particulate matters. To condition the air further, heat reclaim ventilation is installed on the corridors for refrigerant cooling to take place. The output air from the HRV system is then passed through diffusers placed on the walls inside the classroom. Due to the placement of HRV unit on the corridors, the floor to ceiling height inside the classrooms is increased to supplement displacement ventilation.
You are on mute. You are on mute, Dakshin.
Sorry. The energy balance is physically represented throughout the project, whether you see it in building systems or the architecture. ORD International is designed as the net positive energy school. The twofold energy target has been escalated through passive strategies. We are achieving around 60% reduction in total consumption. Analyzing it throughout the year, we found out that the major component of consumption is space conditioning. Starting with the passive strategies, we reduced the conditioning loads by almost 80%. But as we opted for complete mechanical ventilation, the fan usage increased and overall reduction came around 60%. The Noida's climate provides an immense potential for solar power generation. With a total plant size of 290 kilowatt, we are generating around 5 lakh units of energy annually. As you can see, we have not used the whole roof area, providing the opportunity to expand the system if necessary. Although the peak happens in summer months, the systems might cause problems with overheating. We have tried to minimize that effect. We have fixed the plant size according to the peak consumption, which is during August in our case, to round the electricity bills even monthly. Being net positive, we will have to sell the excess electricity back to government only as per laws defined by the state. We adopted gross metering because the limit on net metering in UP was only 10 kilowatt. The surplus will get 2 rupees per unit according to the gross metering laws.
We have created a closed net zero water cycle on our site where the sum of water used from alternate sources and the water recharged to the ground is equal to our total water demand. Using efficient water management strategies, we brought down the indoor water consumption by 63% and landscape water demand by 70% from the base case. This diagram provides an overview of the multiple pathways designed for water flow within the site which helped us achieve a water balance. Fresh water sources supply the initial water demand for the various uses, which then starts 2 cycles of water reuse, one through the phyto treatment plant for black water and the other through grey water treatment plant. For on-site black water treatment, we use phyto-rid wastewater technology as a cost-effective, natural and self-sustainable treatment system. Grey water is treated using a sand filter designed according to the daily volume of water to be treated on site. It decreases the pH of grey water and removes all color and odor. This is followed by a UV treatment to kill any virus present and make the water fit for potable use. Both these treatment methods are a combination of physical, chemical, and biological processes and work without electricity, with minimum maintenance and less manpower. 100% of the wastewater is treated and handled on site, and there is no wastewater discharge. Rainwater harvested from the roof is made fit for drinking by passing it through a vortex filter before it goes into the storage tank. About the water management strategies that helped us achieve the results, our site has 28% plant cover with native plants and xeriscaping that require little to no irrigation. 41% of the rainwater falling on site is reused and the rest is recharged to the ground aquifers. All plumbing fixtures used are highly water efficient and have low flow rates. Instead of using hard paving materials, we use permeable pavers made of 100% post-consumer recycled, high-density polyethylene with a stone reservoir underneath, which helps with stormwater management and recharges groundwater. We have also placed interactive dashboards throughout the school, which display the students' daily water usage and inspire them to decrease unnecessary wastage.
The innovative use of spaces makes it possible for the same space to be used for various purposes. Making use of limited space available, we are using adaptive and easy to install modular pavilions. These kits can be installed in any desired combination to create a range of different kinds of spaces catering to different needs and functions. This range of reusability is further increased by the variety of partial and full covers for the sides of the module. These modules can be used as relaxing spots for students in the courtyards or kiosks for school fete. It can even be used for open exhibitions at bus stand area. Changing the size and scale of the modules further expands its usability. Stage for functions and podiums being examples of useful elements for school. It can even be rented out for any other purpose.
We also have innovative sunlight catching units to focus on the natural light and use it where it cannot reach easily. This light brings a feeling of skylights in the spaces where they are not possible. Moreover, the real-time light intensity brings beautiful variations during the day. The optical lamps work on the concept of concentrating the natural light using convex lenses. It is then directed to optical fibers taking to the space needed to be lighted. The optical fibers diminish the loss of energy during internal reflection and hence more useful for this technique. The intensity of light output depends on the number of units. So we have worked out the assemblies as per our requirement. However, the assemblies can be standardized as per the space requirements. The light intensity in fibers can be maintained up to 20 meters. Hence, the modules are designed small enough to be installed even on the sunshades. This method will allow us to light up the lower floors if the building is high enough.
Building automated systems are not a new concept. They help manage and maintain the building systems from a central space. We added these as a measure to help with the administration. We've used Smart Sol, an innovative tracker by Avrio Energy, which tracks the equipment's health, energy consumption, and generation. It also allows comparison and even sets limits for usage. Displaying the data collected to students through interactive dashboards creates energy awareness in their early life. We intend to lay the groundwork for students to learn energy saving habits, engaging them actively in our attempts towards a green future. The kid-friendly graphics will display information like weather conditions, the amount of electricity generated by the PVs, amount of energy and water used in each space. This creates an opportunity to hold energy conservation competitions between classrooms as a fun way to motivate children and help them gain environmental literacy. For structure, we are using a column beam frame structure in the educational building. The multipurpose hall has a truss system with the ceiling on the truss tilted at 5 degrees to help with solar power generation.
Our school has been designed to withstand natural disasters like earthquakes, fire, and situations like energy and water shortage. The building is compliant with the structural code and other fire norms. In case of a water failure, the building will sustain itself for 7 days on the freshwater storage on site. The roof has space for future expansion of the solar panel system. In case of a power failure, we can run the operations directly from solar using the DG set as a reference voltage by using smart inverters, removing the need for battery storage. In case of a pandemic or an emergency, the multipurpose hall can be converted into a resilient shelter and can house numerous modular units. The hall also has kitchen on the ground floor which can be converted into a community kitchen. Also, the retracting partition walls can be moved along to create spaces comfortable enough to use even in case of a pandemic like COVID. To meet the extended demand for fresh air requirements, VRF outdoor units can be increased in modules without affecting the internal systems. All the assemblies and building materials were chosen from near surroundings, saving both fuel and transportation costs. Only agrocrete blocks provided by an industry partner are bought from Roorkee.
The total project estimate is about 45 crores, coming around 2800 rupees per square feet. It is under the client budget of 3000 rupees per square feet. The total incremental cost is around 5 crores, but as the school typology has higher profit margins, this can be covered in the very first academic year with full occupancy. Starting the other way, we found out that the minimum fees required for our school with a profit margin of 30% is around 1,30,000. This is almost 40% of what nearby IB schools charge. Here, we can see that the major part of expenses goes into staff salaries. The plotted graph shows annual profit amounts after adding material depreciation and taxes. The profit margin increases from 20%, helping to get the building cost back in under 7 years. The ROI increases from 6% and goes up. The life cycle analysis of the added services shows us that we are saving more money than it takes for a new one. This makes a big difference in operating costs, catering to the community indirectly by reducing the school fees if the profit is kept safe. As per the client's requirements, we have checked the compatibility of our project for LEED certification. With 81 achievable points, the building is eligible for platinum rating from LEED, fulfilling the client's demand.
While designing and planning the building, we considered all the stakeholders. Along with the primary users, we have also tried to cater to the entire community. We undertook the design of the school not as a mere architectural project to be completed, but as an opportunity to shape young minds for a brighter and happier future. While ORD International School provides its students with numerous opportunities to explore and learn about sustainability, for other schools, it provides a prototype, learnings from which can be applied to schools all across the country. Working on the various aspects of this project has enhanced our understanding of architecture as a comprehensive field aided by several other industries. Like the students of ORD International School to whom we wish to impart knowledge, we too are taking a lot with us from this project. The team has developed a deep connection and understanding with each other despite these challenging times. Lastly, we would like to thank all the people who helped and supported us through this journey, our professors for guiding us through these months, our project partner for providing us with a great project and his cooperation, industry partners for sparing their valuable time to educate us about various systems and materials, and the Solar Decathlon India team for not only giving us this opportunity to experience designing a net zero building, but also for providing us with detailed learning modules and constant support and guidance. Thank you.
Thank you, team. That was a superb, insightful presentation. I'll now take the questions from the jury members. Isaac, do you have any question? I'll start with you.
Am I audible?
Yeah, you're audible, Isaac.
Okay. So once again, you see, Dakshil, Sheen, Pratyush, and Aman, I must commend you for a very well done job. And even though I had some connectivity problems, but I was able to really understand also from your report, which I went through, that you have done a very good and painstaking job. So I have just a question on your wind tower. Can you hear
Isaac,
me?
we lost you, it seems. Yeah, now we can hear you. We are lost you in between. Now we can hear you. Hello.
I just want to talk to you or just inquire about your experience with the agrocrete, which you are thinking of using it in your as your insulation. So what is your experience with agrocrete, and how do you think that it will be, uh, in terms of its efficiency? I think that's a great idea that.
We lost Isaac in between again. I'll move to Carl. Carl, do you want to go next?
Hi, Team Arkons. Am I audible, Gaurav?
Yeah, you're audible, Carl.
Okay, so hi, and first and foremost, congratulations to each one of you. Wonderful presentation, very well and thoroughly put together. Your reports were also the same. I have a few comments which I had kind of put them together in the first round as well. And if you feel these comments are appropriate, maybe you want to take them further in your careers. You've proposed a basement. There's nothing wrong in a basement. It's I just recommend that when you develop this design further, you want to consider how to make that basement naturally ventilated, because your a basement is going to have a 24/7, 365-day energy demand and energy drain on the building. So if you can make that, and whether you've taken that into your calculation also, I'm not entirely sure. That's one comment. Also, you also want to look at what is your cut to fill ratio with regards to your basement, whether you've been able to use that soil appropriately. Uh, your classrooms in your middle block, you've made a cutout that goes across north and south. You probably want to stagger that cutout, give the breezes through the corridors. That's another small comment. Uh, Isaac was talking about the wind towers. I'm not sure exactly what his question was, but my question is, your wind towers, I saw them on slide 18, are adjacent to a high-rise building. So how exactly? I mean, was the wind towers a predetermined idea, or was it site-specific? It's okay, regardless of what your answer is. It's a good idea, nevertheless. Yeah, that's it. These are questions from me.
Thanks, Carl. Team, do you want to address that?
Yeah, sure. To start with the question about the wind tower, like the wind tower will draw in air through mechanical means. So, like Delhi being the site which does not have high wind flow during throughout the year, so we proposed the mechanical means to draw in air through the catchers which would be placed above, and the catchers will also have jalis in them to avoid any kind of birds or insects to go through into inside the wind tower.
Okay, thanks. I'll move ahead to Harsh. Harsh, any comments or questions?
Yeah, I have. Thank you. So I think I agree with the other two jurors that it's a job well done. I think you were very convincing and about the holistic thinking you've done on the project. Various factors, various things have been accounted for, and the way you put it also, is very clear, right? Some things can be argued differently, but the way you argue is something quite clear. And I think having that argument clear itself is good. That's my first thing I really liked about your strategy for massing and site and circulation. I think that was standing out quite a bit. I have a I have a couple of comments. You don't need to react to everything, but you can take up some of them. First is that I thought that the massing, especially the courtyards that are created, essentially are still quite high, which means that despite your stepping down, essentially your ground and grass is essentially in shade, pretty much a lot of the year, actually, definitely the winter, right? Which means that, in winters when it's cold, it's about 10, 12 degrees outside, it's not the ideal place for, kids to play. So that means you need to identify a winter space as well. This was a strategy, I really feel for outdoors. You must have, summer and winter spaces worked out. The other, one major comment I have is that I would really advise you to, relook at a fully mechanically ventilated building, right? I do understand that you mentioned there is air quality problems in Delhi, but from my experience and practice that, systems fail, air qualities tend to improve. The whole year, the air quality is not bad. There will be definitely 30-40% of the year when air quality is okay. And naturally ventilating your classrooms, which you've already kept thin, is quite easy by providing a window on the corridor side, right? Which you've not done, which can easily be done. And I think you should really look at the building also naturally ventilated for a part of the year. The last point I want to say is that, I read in your report that there is a night and a day cycle to the wind tower, right? It's an innovative idea, and I think it needs to be taken to the next level. So, I mean, I think it's interesting, but I think there is something about it which is not fully convincing, in the sense that, you're running the wind tower at night to cool the mass, right, of just the towers. While my logic is that if you're creating the cool air, why are you throwing it outside? Might as well circulate it inside the building and cool the mass of the building itself, right? And to that logic, you have put false ceilings, right? But for when you start cooling the mass of the building, obviously you'll have to think about not having the false ceilings, because your body will essentially kind of radiate to the cool concrete and so on and so forth, right? So I would leave you with these thoughts. I think it's interesting. If you want to react, I would be very happy to hear about your thinking on it.
So we'll start by answering about the courtyard that you said that we don't have a window space. So our southern courtyard is 15 meters wide, and the height of the south block is also approximately 15 meters. It's 3 stories high. So we almost get a 1:1 ratio for the southern courtyard. And with the shadow analysis that we did on multiple softwares, we were getting adequate sunlight there during the winters. So we had designed that as a winter courtyard.
All right. 1:1 proportion will get you the light onto the building across, but not onto the grass, right? But if you've done some simulation, I mean, it's great. I think about it. Yeah, got it.
So then about about the basement part.
Okay. Go ahead. Keep your answer short, sir.
About the basement parking, we needed one car park per 100 occupants to comply with the Noida bylaw, and due to site constraints, we could not have provided this on site with the number of occupants we had and this smaller site area. So we had to go for a basement parking. And about reutilization of the basement, if like we can have adaptive reuse there with the modular pods that we've made. And then the basement also houses multiple services that we have, like a generator, a pump room. Now, we consulted a few architects about this, like Mr. Vinod Gupta, who designed Pathway School, and he said that according to the bylaws, we have to make a basement, but this can be discussed with the authorities, and we do not need to construct one, but just for educational purposes, since we're students here, we decided to comply with the bylaws and add a basement.
Sure.
Thank
Any
you.
reaction, just last reaction to the important point, which is naturally ventilating your build space, which is quite important, I really feel. You should not, in this age, really look at a fully and closed facade, right, without openable windows and things like that.
So I would like to respond here. The buildings, the windows are open, 30% openable. So we have the windows openable, but due to the air quality, we are not opening it. And your talk regarding the ventilators on the corridor side, we have provided it in the doubly loaded corridor, the middle block, but not that singly loaded corridor block.
Okay, so something you can, I mean, I understand you can look into, right?
Yes.
So, Isaac, any last comments? We are running short on time, but any last comments?
So sorry, my net. Yeah, so
No, it's
I
totally
just want
fine.
to finish off. Just one very quick question. Am I audible? Yeah.
Yes, you are audible.
Hello.
Yes, yes, Isaac, we can hear you.
You're audible.
Okay. So basically, one question.
Okay. There's some
I had
connectivity.
a small point for you guys. You've proposed cardboard as a material for the kindergarten. It's a nice idea and all of that. But with the deteriorating air quality, there are some studies to demonstrate that the ratio of asthmatic kids has gone up substantially in the last 25 years. And cardboard inherently has dust mites. I'm speaking from personal experience. So just look into that a little in more detail. You might reconsider your proposal.
So we
Yeah,
did
sure,
look
sir.
into that a little. Did look into that a little, and we found that there are certain finishes that we can use on the cardboard to prevent the deterioration of cardboard and waterproofing and everything.
Even we in our academic projects also we have designed some cardboard furnitures during our first year. So like we are equipped with it. Even our jury that time also told about these methods that are happening in the markets.
Okay, so I think team that was a good presentation and a good informative presentation for all of us. So thank you. Now to the jury members, we'll have another 5 minutes of break before the next presentations would start. Thank you, team.
Thank you, right?
Thank you,
Well
sir.
done.
Thank you.
Thank
Thank
you
you
guys.
for all
All
the
the best.
comments.
Hello, team. We'll start in another couple of minutes.
Hello.
Yeah, we can
Hello,
hear
sir.
you. We can hear
Yeah.
you. Just a minute. Wait, just a minute.
No. Can you
Yeah,
please tell me how to collapse this chat box, which is
which chat?
towards the right of my screen?
No, it would go. So it will be there. It would be.
Okay. All right.
If you want to view the presentation, you can do it on the full screen mode. If you hover over the main screen above, you can go to the full screen.
Hello.
Yeah, just we'll wait for another minute.
Uh, Actually, I was just asking if to my teammates that if we can see each other right now, or
Just
like
just a
I'm
minute.
not
Just
able to.
yeah, yeah. Be there in the backstage. Just a minute. So, hello everyone. Our next presentation is from Team Tejasvi. They have worked on a student life center in IIT Ropar. Uh, their their project partner is Indian Institute of Technology Ropar. And so before we start, let's have a quick AV check with all the presenters here. So I'll start with Prabjot. Can you just have, can you speak up something?
Hello. How are you?
Yeah, thanks. Now may I request Mehak for a
Hello.
quick audio check? Yeah, thank you. Aditya, I can't hear you, Aditya. No, I still can't hear you. No, I still can't hear you.
Wait a minute.
Now I could hear you now.
Now you can hear me.
I could hear you, but there's some disturbance from your end. Could you speak up now again, once again?
Yeah, sure. Am I now audible?
You are, but there is some minute disturbance at your end. Keep yourself on mute whenever not required.
Sure.
Okay, thanks. Mazhar, can we have a quick check
Yeah,
at
am
your
I
end?
audible?
Yeah, thank you. So, team, please share your screen and go into your presentation mode. You.
Is my screen
Uh,
visible?
yeah, your screen is visible. Thank you. So the jury members are in the backstage and they can listen to you. And so you will have 25 minutes to present your work. At the 28th minute, I'll ring this. So that will indicate that the last 5 minutes are remaining for your team to present. There will be no 26th minute, so it's a hard stop at 25. After that, we'll have a 15 minutes of Q&A. So keep your answers direct and as short as possible. And okay, the team, so the stage is all yours, and your time starts just a second. Yeah, your time starts now.
So, good afternoon and a warm welcome to all the jury, chief guests, the audience, and congratulations to all participant teams who, just like us, strive toward achieving net zero energy solutions in these uncertain times, and to all those who were connected to Solar Decathlon directly or indirectly. So, introducing ourselves, I, Prabjot Singh, team lead, along with my team members Mazhar, Aditya, and Mehak, are here to represent Team Tejasvi, and we will be sharing our project presentation with you all. Our team is a multidisciplinary 11-member team consisting of an architect and engineers from various disciplines such as civil engineering, chemical engineering, mechanical engineering, and electrical engineering. Now, before moving to our project, it is important to understand background of IIT Ropar. Well, IIT Ropar is one of the new IITs established by MHRD under the Government of India, and IIT Ropar campus has been awarded 5-star GRIA rating, one of the highest national ratings for green buildings. IIT Ropar students are passionate about cultural, technical, and sports activities. We have various fests and events throughout the year where we, as a student, hone up our skills and passions. So, IIT Ropar is a prestigious institute dedicated itself to let students develop into professionals who excel in various fields. But here is something we want to tell. These are some pictures of our campus, which is spread throughout the 550 acres. As beautiful it is, there is something missing. Well, if you see, excluding hostel and residential quarters and sports field, as you can see in the first and fourth building, most of these buildings are the educational buildings, and of course, it explains why our college is one of the leading institute in terms of academic excellence in our country. However, the race of being best generally gets compromised with the hobbies and passions of students. This is reflected in case of our campus too. There is no building which acts as a single roof to the hobbies of the student community, while numerous building for academia. Therefore, there has been always been demand from students as well as faculties to have such a building which shall act as an outburst to academics. Next slide. So, what is a student life center? A building that shall habitate students' passions and aspirations. A student life center is a facility which is devoted to recreation and socialization of students. It is a must-have building for any institution so that students can pursue their passions along with studies. Our main occupants include students involved in various activities. So, by participating in Solar Decathlon, we are actually working on very innovative concept to bring in our building, which which we proudly acclaim as of the students, for the students, and by the students, a testimonial to what students can achieve by themselves. And we thanks to SDI for this opportunity. So, of course, our team went through a rigorous workflow, which consisted of various stages of conducting surveys among IIT Roper students, thinking up of ideas at rudimentary stages to cater their demands, dividing into teams of architectural, MEP, civil works, which further we get consulted with TRG members, experts, faculties, and then performed various iterations and then finalized our work. In the upcoming slides, we will be elaborating our project achievements and how we made a net zero energy and net positive water performance building. So next slide. So yeah, over to Mac.
Student Life Center, the building located inside the campus of IIT Roper. Inside the campus, student of our project partner IIT Roper to cherish their hobbies in their spare time. The climate zone of Roper is subtropical climate and it also lies under the seismic zone 4. The total area of our building is 4,500 meters square, in which the total build-up area of our building is 2,400 meters square, and we are successful to achieve the 50% achievement of educational area. We categorize our building into 4 subtropic categories, in which that is sports, cultural, technical, and interactive spaces. All the cultural areas are shifted to the second floor as some of our Indian students hesitate to perform in front of the people and all the technical rooms are shifted to the top floor, that is the third floor, so that the natural acoustics are provided to these rooms. A successful survey has been done amongst the students of IIT Roper to make the building of the students, for the students, and by the students of IIT Roper, for whom actually the building has been designed. Here is a small walkthrough of our building. So now moving towards the resilience. The site provided is located near a rivulet named Burki, which tends to flood during the monsoon season. So following measures have been taken in consideration while designing the building. Storage tanks for emergency during water scarcity, generators and other power cut backups have been taken in consideration. Even contactless thermometers and various types of sanitizer dispensers, by keeping the scenario of this pandemic in mind. The fire detection alarm systems and fire extinguishers have been taken in consideration. The very next best thing to remember while designing was the U value. Now, what is the U value? U value is the rate of transfer of heat per unit area per unit temperature difference across the wall. The better insulated the structure is, the lower is the U value. So we tried to keep all the parameters in mind while designing our students' life center. Now moving towards Prabjot for energy performance.
So yeah. So you just saw our optimization for building envelopes, combining and integrating it with HVAC and lighting solution. Next slide. Uh, so we were able to reduce energy consumption by 73% or three-fourths of the base case, that is from 703 megawatt hour to 193 megawatt hour. These are some optimization, as you can see, such as LED with control scheduling, VRF systems, which by opting to which we got the above stated results. Here we have got energy generation of 220 megawatt hour, which shall be catering to the demand of any energy consumption. Moving forward. So yeah, as you can see in the graph here, these are the stepwise optimizations by optimizing openings, lightning, building envelope, and finally HVAC. We were able to reduce by 73%. Our proposed case EPI is 72.3 in standard units, which compared to super energy efficient EPI is 70, which is 78 in case of college, university buildings in composite climate. So thus we safely comply with the net zero energy building standards. Also, in terms of energy, we can say that around we can operate around four such our proposed case building with what was in one base case building, what would be required for one base case building. In terms of cost, we have saved 43 lakhs of expenditure on energy consumption by switching over to renewable energy and also reducing the energy consumption. Carbon footprint reduction is equivalent to planting 6,000 trees. Next slide. So let us explore our HVAC solutions. Moving on. So ASHRAE's 55 2017 adaptive comfort model is followed with the operative temperature control and 80% acceptability. The goal is to make building energy efficient without compromising with the comfort and air quality in the building. Yeah, so 96-ton VRF was placed with which reduced our consumption by 40%. It not only improved our energy performance but also helped us improve in the water performance. Next. Moving on to lighting and electrical operations. Moving forward. We opted for smart lighting using various techniques, including energy efficient LEDs, combination with smart controllers, maximizing use of light, natural, and minimizing loss, etc. And using various sensors, by which we were reduced the consumption from 112 to 40 around 48.78 megawatt hour in terms of for lighting, which is at around two times reduction. Apart from this, we also introduced innovative electricity generators called piezoelectric tiles, offered by Pavegen. DG backup in case of energy is not available from solar is also integrated in our building. Next slide. So this was all on the some various standard and optimizing techniques, by which our base case, which you can see on the left, the slacky large graph, has been reduced and compacted by our team and student efforts to the proposed case of 193. So while we have achieved a net zero target in energy, that's not all. Our team would like to share its feat in water performance, for which I would be inviting Mazhar on board.
Thanks, Prabjot. So, a very good afternoon to everyone. Let's walk you through the building's water performance and first address the question as to why is water being given so much importance in a student life center. Moving forward, that's because according to the WHO, only 0.007% of Earth's water is usable, and much lesser is drinkable, putting the world population in a precarious situation, which may be the root cause of World War III if at all it happens. In India, rainwater literally goes to waste, leading to water shortages despite heavy rainfall. Existing water resources are under severe threat due to overexploitation and waste dumping. Hence, as responsible engineers and future leaders, it is imperative for us to address these issues at least at the local level. But why at IIT Ropar? And why would the institute take an interest in implementing our strategies? The reason is that IIT Ropar aims to provide quality technical education and create leaders who would do good for society and the environment. Implementation of this project will encourage the institute fraternity to appreciate the importance of sustainability and managing water as an indispensable resource. Now, recently, the Department of Science and Technology, Government of India, approved a sum of rupees 110 crores for IIT Ropar to set up an agriculture and water technology development hub, or AWAD, to promote interdisciplinary research in the domains of agriculture and water. Having a live, extensive water management project running on the campus will definitely provide a big push to the initiative. Finally, the water management project will also benefit the local population and is in line with the Institute's ideals of contribution to knowledge, contribution to the nation, and contribution to society. And we'll speak more about it in subsequent slides. So, moving forward, what will we achieve and how? Well, the use of low flow fixtures, xeriscaping, and efficient irrigation will help reduce consumption by 30.4% compared to the base case. For a water sufficient building, this isn't enough, and the demand must be met by on site resources. Hence, extensive rainwater harvesting systems will be deployed, and this would save rupees 50.5k on annual water bills for the SLC. अभी amount छोटा लग रहा होगा, बिल्कुल. But that is because water is an inexpensive commodity. It costs just rupees 25 for 1,000 liters. But look at the reduction in dependence on offsite resources. A whopping 81.3% reduction, thanks to the use of efficient systems and harvesting 20.8 lakh liters of rainwater. Besides, we also recycle wastewater, and the output of the recycling system is 9.4 lakh liters. The cumulative result is that the building is net positive by 12.8 lakh liters. Multi-step wastewater treatment processes ensure the quality of the effluent meets acceptable standards, and thus the sewage lines and water bodies won't have to bear the burden of 16.3 lakh liters of dirty water. Moving forward, okay, finally, what is the tangible impact of all this? So, due to dumping of treated water, quality of water bodies and underground reserves will be safeguarded. Second, if carried out directly under the aegis of Awadh, this project will serve dual purposes of research and water cycle management of the SLC, helping the institute cut costs. Finally, being significantly net positive allows us to add a whopping 14.2 lakh liters to underground reserves. To get a better feel, let's look at it from another perspective. Punjab is the food bowl of India and requires enormous quantities of water to sustain its agricultural activity. Ropar is no different and fields surround our campus. These 14.2 lakh liters can take care of the irrigation requirement of 16 acres of land for the entire Rabi season to produce 1600 kgs of wheat. The yellow polygon shows how big a patch that is. Because this project helps the nearby farmers, protects water resources, and attempts to solve the water crisis, it truly upholds the golden ideals of IIT Ropar. Moving forward, now let's walk you through the innovative approaches, new technology, and ubiquitous yet very effective approaches we will adopt to add to the sustainability of our SLC. Moving forward, the first on the list is for harnessing more solar energy. We plan to replace normal window glass with transparent solar glass, which absorbs a portion of the solar spectrum invisible to the naked eye and converts it to electricity, while allowing visible light to pass through. This approach will generate 32.3 kilowatts of power, capable of powering 9700 LED bulbs. The next pertains to treatment of grey water. To increase the efficiency of the root zone bed, we plan to mix the soil with oil and decayed organic matter for moisture retention and prevention of evaporation from the soil. Also, mushrooms will be cultured in the soil to have a symbiotic relation with other treatment plants, thereby increasing the overall nutrient absorption capacity and thus efficiency of the system. Also, low flow fixtures are necessary to reduce consumption, but they cost 1.5 to 2 times or more than normal fixtures. Hence, to significantly reduce costs, we will be fitting the normal fixtures with aerators, which cost just a few hundred rupees. Also, keeping the pandemic in mind, hygiene aerators with one finger touch on or off function can be installed to minimize contact. Moving forward, another energy generation strategy is to use piezoelectric tiles. As people step on them, electromagnetic generators below are compressed, producing 5 watts of power per step. This will encourage students to move around and be active. High movement areas like dance floors and badminton courts are best suited. Although initial investments will be high, high returns are expected considering the tiles have a lifespan of over 20 years. Finally, for effective drainage all around the year and junking aesthetically unappealing roads lined with drains, we plan to use plastic roads. Rainwater falling on the road quickly drains into the storage cavity below, from where it can be channelized to a harvesting tank or allowed to infiltrate into the soil below. A whopping 64,000 kgs of plastic waste will be accommodated for paving works of our building. This approach also reduces the carbon footprint by 52 to 72% compared to conventional paving, according to a study. Well, that's it from my side. Over to you, Aditya.
Thanks, Mazhar. Now, I would like to take this opportunity to talk about the affordability of the project. Next. So, when we were designing the project to make it cost effective, we decided to go with new construction materials and uh, equipments which gives high returns without compromising on the qualities. For example, using a pre-stressed post-tension concrete instead of conventional concrete, as they are thin, more stronger, and required less material to build. Also, we listed all the sources from where we can get precasted building segments, which not only help in getting better quality, but also save our 5 months of our precious construction time. Now, moving to the operational part of the project. By changing default lighting with the LEDs having feature of control scheduling, we are able to reduce our energy consumption by a remarkable 14%. Also, based on our energy calculation, we found that we have excess of solar energy, which we decided to send back to the local power grid, and thus creating a source of revenue. This this is illustrated in this graph also. As we can see, with an initial investment of nearly 50 lakh rupees, we on purchasing solar panels and its equipment, we get a return of investment after 5 years of its operating. Moving forward, and to the scalability and market potential of the project. Next. So we try to make a project which not only meets user demands but also provides an open, safe environment for recreation and also a space for learning and social interaction. These are some stats of the problems faced by the Indian students. Like 80% of the respondents feel that they are overwhelmed by their responsibilities as a student. Another, that 50% of student rated that their mental health issues are average or poor. So based considering these stats, we decided to create a space where the student can do recreational activities apart from their academic activities to cope with his mental health issues. Moving forward, also, with the ideas like leasing some of the areas of the building for the shops, cafe, and reducing the maintenance cost by 8%, we are able to achieve internal rate of return of 7.33% from our base case of 0.25%. Also, after completion of 6 years of our project, we are able to generate income of 66 million rupees. Next. Now, moving forward to the topic market potential. With the rising need of energy efficient green building, we decided to take advantage of its market, which expected to grow to $132 billion by 2024 with a growth rate of 5.5%. Moving forward, moving to the last topic of presentation, market potential of the energy efficient solution which we are implementing in our project. The technology of aerator helps us reducing the water losses by a remarkable 93% with a return of investment of less than 6 months. Also, the market of piezoelectric devices, which converts pressure into electric energy, is expected to grow to a 35 billion by 2025, with an annual cumulative growth rate of 3.7%. With this, we come to an end of our presentation. We thank our jury and audience for their kind attention. And now we are open for the questions. Thank you.
Sir, you are mute.
Thank you. Well done, team. You have completed your presentation well within the time. So that's and that. I'll open the floor for the jury questions. Isaac, sir, I'll go to you first.
Okay, can you hear me?
Yeah, we could.
Yes.
Okay. So I want to commend the team that you have done quite a few interesting steps that you have conducted a survey, right? That's very interesting. You have chosen to use the alternate modern technologies for fast construction. And I think that's a good step that you have taken. And also you have tried a few things like the social innovation part, and that's quite interesting. Uh, may I ask you if you ever thought of, one of the major problems of Punjab, and that is again use of the localized materials, and that is basically the agro waste, which is being generated in hundreds of tons. Uh, was there any thought in the direction of whether you can use such materials for construction.
Actually, yes, sir. We decided to use the waste generated to for the construction of the roads. Actually, using only 10 to 20% of the plastic for a road construction material, it helps to save almost 1 lakh rupees of the road construction per kilometer.
Okay, I was referring more to the localized agricultural waste, but anyway, we can proceed.
Okay, thank you, Isaac. I'll move to Pal.
Hi, Team Tejasvi. Uh, Thank you for your presentation. And my comments will be very small. I think you all have made a great effort in time to bring out all the engineering aspects and the new ways of doing things into the building. I just feel that maybe we want to once again look at the spatial qualities in terms of the architecture. Uh, you know, the kind of natural light that you bring into the building or the spaces that are getting created, because you're ultimately making a building for students and for recreation, and the spaces want to be speaking that same language. So while I think you've done a stellar job in terms of all of the engineering aspects, this is one thing that I would request you all as a team to once again get together and have a look at. And even if it means post this today's presentation, if you want to take some guidance or advice on that, I'd be happy to sit with you guys on that. It's just a small comment from my side.
Thank you, sir. Sir, we had pondered over this. We had just like few things. One of the thing was that our climate is somewhat what we say humid compare because we are in our Ropar. We have Satluj River flowing near our campus. So there is a humidity. So we wanted to minimize the humid and apart from that, increasing on the interaction spaces, we had provided a courtyard in replacement of that. So this was our from our side, and yes, we would be happy to listen from you on improvement.
Yes, sir. And adding to this, actually, we have provided 3 continuous courtyards, and we tried to incorporate jalis wherever possible, so that natural ventilation and light will always be there.
Thank you. I'll move to Harsh.
Okay. Team Tejasvi, thank you very much. I think I also felt that you had a lot of ideas, and some of them are quite interesting. So one of the things I feel is that for any in-depth work, you'll have to select a few later on, as you move forward in your architectural education and further, and you'll have to dive deeper into it. So that's one feeling I have. And there my guidance would be that you should select the ideas which have the option of maximum impact, right? We are all here to make some impact on the onslaught of climate change and energy consumptions rising. So some of the ideas may actually be very interesting, but they may not have cannot be scaled. So that you'll have to really compare them. So that's my gut feeling, that you have to kind of filter through the really worthy ones, right? So my personal reaction to piezoelectric solutions are that they're very interesting for bespoke kind of applications, may not have the scale impact into them, but you have many more ideas which you need to kind of compare them to. Now One question I have for you, is based on the report I saw. So I realized that you, as a team, have spent a lot of time looking at the engineering aspects of it and actually running a lot of simulations and really getting into it. And that's well done. I think that gives you a lot of understanding on the way systems and the energetically the kind of enclosure works, right? So one of the things which I was a little unconvinced about, and I wanted to raise it to you to see your reaction, is that you you finally selected a window to wall ratio of around 15%, right? Which I felt is quite low. And then I also see in your analysis that you have heating load. That means at some points in winters, your building actually does require heating, right? So my question there is that do you think there was a possibility where we could have looked at far higher glass percentages, maybe on the south side, and actually allowed all of that to come in and kind of explore the passive, kind of ideas where, the sun heats up the building and you could have really minimized that heating load?
So on the first of all, on the engineering part, actually in our team only one architect student is there. Rest all are engineering students. So that's the thing. That's why our report is more on the engineering side. And secondly, the glass we didn't use because of the affordability, first of all. And the second thing is it's not easily available in Punjab. It's not the local material of Punjab, so we didn't use much of the glass there.
Okay, sure. So that's something, you have to kind of look into the pros and cons of it and, what's of benefit and stuff like that. But my one quick reaction to your thing that there was only one architect, great. I think, lots of engineers are also required. So, the future professional, whether it's architect or engineer, is somewhere in the middle of things, right? Especially people who are dealing with energy efficiency. They are kind of talking both languages. So that's great, right? I mean, nothing wrong with that. So all the best. Thank you.
Thank you so much, Harsh. We
Sorry to
have,
interrupt.
yeah,
If you'd allow me to chip in, Harsh sir,
yeah,
Yeah,
I'd like to
sure.
add to the answer regarding the heating load. So the problem is that the student life center actually comes to life during the evening hours. And in
Hmm.
Punjab, actually what happens is that the sun sets in between 5 to 5:30 at that time. So basically all the heating load which is required is predominantly post dusk. And that is
Hmm.
one thing which we probably might not be able to avoid. And
Hmm.
further, if you compare it with the cooling load, it is quite less. So that is
Hmm.
just what I wanted to add.
thank you so much. We have Dr. Dheeraj from the project partner side who had been listening to your presentation. I'll take some concluding remarks from his end. Yeah, so you're on mute. Yeah.
Yeah. So actually, I'm truly speaking, I'm a little late. But the kind of effort the kids have put in these difficult times when everybody, like due to COVID, also our education online mode and giving quizzes and all, it was very difficult time, like not from the student point of view but from my as a teacher point of view also. But I have seen their reports, I have seen their presentation. I think the kind of effort that they have put together as a team, that's enormous. And yeah, I will leave to the jury how they want to judge it. But from my side, the kind of effort required to compete, they were at par, and they have shown what it really takes to make a good proposal. So that will be from my side. Yeah.
Thank you so much,
Yeah.
Dr. Dheeraj.
Yeah.
Uh, that were good words to end the presentation with. So now jury will take another longer break. So we'll now join back again at 3:40 for the next presentation. Uh, so so teams, you may log out of this call, and jury members, I'll see you again at 3:40. So thank you so
Fine.
much for your time. Thank you so
Thank you.
much,
Thank
sir.
you.
Bye.
Thank you.
Thank you. Bye. Yeah.
Hello everyone. We will start in 10 minutes. We will start at 4. So be there. Thank you. Hello, everyone. Welcome back. We are into the last presentation in our division for educational building. Uh, so the fifth presentation, uh, the fifth presentation is from the team Polymorph. They have worked on an ORD International School in Noida. Their project partner is ORD Towers. So before I start in with, we will have a quick A/B check with the team. So, so I'll start with Hardik. Hi, Hardik.
Hello, so can you
Yeah,
hear me?
yeah. Thank you. Uh, Priyanshu,
Hello, good afternoon.
good afternoon. Soumya,
Hello.
uh, Supreme,
Hope you can hear me.
hi. Hi, Joseph.
Good afternoon, sir.
Good afternoon. Uh, may I request the team to please share their screen and go to the presentation mode? Yeah, I have the presentations ready. Okay. So team, you will have 25 minutes to present your work. Uh, at the 20th minute, I would be ringing a bell, something like this. So it will be an indication that you're into the last 5 minutes of your presentation. You won't be getting that 26 minute. So, which means at 25 minutes, I'll have to ask you to stop your presentation. After that, we will have a 15-minute Q&A session where the jury members would give you comments and ask for the may ask you some questions. And please keep your answers direct and to the point. We are expecting your project partner might also join. If he joins us, we will hear for his conclusive remarks at the end of your presentation. So, team, all the best, and the stage is all yours. I'm starting with the timer now.
A very good afternoon to the esteemed members of the jury, faculty, viewers watching us live, and our worthy competitors. We are Team Polymor from SPA Delhi, and today we propose our net positive energy school design to you, which strives to provide a sustainable and energy conscious environment, raises new leaders for tomorrow, and gives back to the community.
Our client for the project wanted to team up with students of architecture to develop a school design that would be relevant in current times and provide a center of creativity for the society that would inspire and inculcate a sense of creativity among the students. The site, occupying an area of 15,256 square meters, rests within an upcoming industrial and commercial neighborhood of Noida. Its close proximity to the Greater Noida Expressway ensures a good connectivity with its users. The learning concept of Ananda, Jigyasa, and Sadhana is integrated into the building form of the school. Through our spatial planning, we have tried to create a juxtaposition of traditional and modern ideas of schooling and building design, which conform to the International Baccalaureate curriculum. After exploring various zoning and massing layouts, we have arrived at a form that takes into consideration aspects such as orientation, lighting, and circulation. The team did an extensive research on how schools function in an IB curriculum. We developed an understanding on how different spaces and activities would interact with each other. So, we zoned out the spaces accordingly to coexist without hampering their experiential quality. The movement across the building was optimized by circulation course at appropriate distances. Boarding and deboarding of buses is a key factor in a well-functioning school. Hence, we identified three major vehicular traffic coming into the site and planned the movement accordingly, so as to maintain efficient traffic flow in the interior and exterior of the site. This view shows how we have incorporated multiple play areas in the building, which can be used by children of different age groups. The school portrays a healthy balance of learning and activity areas interspersed with playful and collaborative multifunctional spaces throughout the building. The two academic blocks are brought together by the central spine, which connects the building and increases interaction. The modular nature of spaces in the buildings makes it easier to accommodate different kinds of functions in spaces of similar character. The spatial arrangement throughout is such that it allows and promotes maximum interaction among the students of similar as well as different age groups and segregating them wherever necessary. The building complex playfully incorporates spaces of varying heights and volumes and plays with lights and shadows to enrich the user experience. The materials for the facade are chosen such that they complement each other not only aesthetically but also contribute to the building's sustainability factor.
In energy, the goal was to reduce the consumption while maintaining good levels of comfort inside the building and then offsetting the energy requirement through a renewable energy system. These were the 6 steps taken in order to achieve an energy efficient building. In our site, the radiation levels on the east and west faces are much higher than the north and south. First step was orientation. Two building blocks with their longer axis along east to west and northeast to southwest, respectively, were connected through a corridor. This minimized the wall area in the high radiation zone while also allowing for mutual shading between the blocks. Second step was zoning. WCs and cores were mostly kept along the high radiation zones to give a thermal buffer to the habitable spaces adjacent to them. Third step was courtyards. Central courtyards with singly loaded corridors provided the possibility of windows on two sides of every space, allowing for cross ventilation. Also, the inclusion of open corridors eliminated the requirement of lighting and mechanical ventilation in them, drastically reducing the energy requirements. Fourth step was openings. Openings were placed mainly towards the north or south walls, which minimized direct solar heat gain and maximized daylighting as confirmed from the simulations. Building modeling. This section briefly explains the occupancy schedules, equipment data, and measures taken for envelope optimization. Based on the case study of how IB schools function, we developed the school's timetable, which would tell us for how long the school function, when it is in break, and how it's working on a limited capacity in a year. We also looked into the occupancy of each classroom and its schedule. Each equipment was chosen for its energy efficiency as well as price and availability. Lifts were also carefully chosen to decrease the overall energy consumption. Based on this, we have been able to arrive at the monthly electricity consumption of all the equipment in the entire building. This particular graph shows monthly heat gains due to occupancy in pink and equipment in violet. This gives us an idea of the amount of internal gains happening inside the building, which would be constant for both the baseline as well as the improved case. Envelope optimization. It was necessary to decrease the external heat gains and maximize daylighting to decrease the load on the active systems, which are lighting and HVAC. Cellulose was chosen as the insulation material. Cellulose is a material derived from recycled waste paper with insulation properties comparable to XPS and a much lower carbon footprint, decreasing the embodied energy of the building drastically. Cellulose filling was used for roof insulation, and a 180 layer decreased the U value by 90% and decreased it to 0.21, which is compliant with Super ECBC. AAC blocks and cellulose panels were used for external wall insulation, and a 100 layer decreased the U value by 89% from 1.9 to 0.21, which is again compliant with Super ECBC. This particular slide shows the glazer diagrams for baseline as well as improved assemblies. Both envelopes are free of condensation. For glazing, a double glass unit with a very low SHGC and U value and a good visible light transmittance was used instead of a single glazing. With an SHGC of 0.25 and a U value of just 1.6, it was compliant with Super ECBC. This graph shows the monthly heat gains through envelope. for baseline in pink and improved case in violet. It demonstrates a reduction of over 50% in the total external heat gains through efficient envelope design. Now we come to active systems. For lighting, LED panels were used instead of the commonly used CFL bulbs. LED panels are aesthetic and much more efficient than CFL bulbs. Daylight sensors were also incorporated, which dim the light to 10% power when the daylight is adequate. As visible in the table, the reduction in lighting power densities was over 70%. For HVAC, a hybrid system was used, consisting of a radiant cooling system with fan coil units and mechanical ventilation. A building management system was also incorporated to keep track of all the energy usage data for better monitoring. This graph shows the final monthly consumptions of all sectors. Baseline data is shown in violet and improved case data is shown in pink. There was significant reduction in the cooling, lighting, and lift energy. Overall, we got a reduction of 29% from the baseline. For renewable energy, we considered various systems such as biomass and wind energy. However, solar energy was the best suited for our site since it gets good amount of solar radiation and could easily be installed on the terrace of our building. For solar photovoltaic systems, LG neon R panels were used, which have a very high efficiency of 22%. The final energy generation was 431,659 units per year. Due to the huge size of over 300 kilowatts, gross metering was done. The final consumption EPI was 18.33, while the generation EPI was 19.49. The final EPI of the whole building was negative 1.16, which makes our building net positive.
Various strategies in developing an efficient water usage cycle have made it possible to reduce the water consumption in the building by 59%. Water, being such an important resource for humans and the National Capital Region already being under a water crisis, we tried conserving it as much as possible. Here, we integrate certain simple yet extremely efficient methods such as fixing fixtures of low flow rates, xeriscaping for landscaping, bioswales to collect water from the landscapes, and recycling the water for flushing in the toilets. The graph explains the decrease in water consumption after using the efficient fixtures with a reduced flow rate. The black water is treated for its solid effluents through the aeration and separation tank, which is further combined with the grey water to be treated together with the anaerobic and baffle digester. Surplus water could be provided for smaller plantations or gardening facilities adjoining the site boundary. Here, the graph shows the monthly water consumption, replenishment, and storage. Therefore, the school consumes around 1 crore 58 lakhs liters of water, generates around 1 crore 64 lakhs liters of water, hence leaving us a surplus of approximately 5 lakhs 59,000 liters annually.
Coming to comfort and environmental quality, our college and hostel being situated in the same climatic region, we had first-hand experience and could anticipate the needs of such a climatic context. We understand the correlation between the thermal comfort, air quality, with respect to the students' performance and their well-being. We started our initial analysis with incorporation of the passive strategies alongside the design process. We also started iterating and optimizing the HVAC system based on the understanding of the school timetable, which helped us to develop a very precise scheduling. Indian model for adaptive comfort was adopted as a thermal comfort model as it was based in the Indian context after studying the occupants' clothing levels, metabolic rates, practices, and how Indians have adopted to it over many years. Based on our initial conditions within the classroom, we modulated the temperatures and humidity conditions to achieve a comfortable environment throughout our operational hours. This was aided by incorporating passive strategies in our initial design development, such as placement of highly reflective surfaces in our northern region and landscaping and softscaping in the remaining 3 sites. Optimization of our exterior envelope helped us to create a thermal buffer and achieve much cooler indoor spaces, which also helped us to achieve a microclimate within our courtyards, and create a much comfortable environment in our corridors and common co-working spaces. Strategic placement of our wards in the building mass directs a constant cool breeze within our courtyards. Cross ventilation was achieved by maintaining a slightly lower pressure in our courtyards and ensuring appropriate window placement and sizing. This ensures movement of air through stack effect. Natural ventilation and use of ceiling fans helped us to achieve comfort for about 25% of our time of our operable hours. Maintaining visual comfort is one of the most important factors within any classroom. We try to provide ample daylight within each classroom. The window and sun shading design allow us to have an area of 67% with at least 90% UDI, which complies to Super ECDC. CFT analysis was run to ensure effective ducting layout of HVAC systems. This was achieved by running multiple iterations of window sizes and their placements, comparing them with the head height within the classrooms and the effective cooling of the volumes occupied by the students. We also paid close attention to the direction of the air movement in order to prevent recirculation of the stale air and to improve the air quality. This overall results in a classroom which maintains its temperature in a comfortable zone throughout the year. Furthermore, in the light of COVID-19 pandemic, we have also ensured 6.5 air changes per hour as per higher limit of ASHRAE standards, and also ensured our CO2 levels are less than 750 ppm in our classroom spaces throughout our operational hours. By incorporating a 3-layer filtration as well as ultraviolet germicidal irradiation units in our AHA units, we kill microbial activity by 60%, which ensures a very good air quality. Coming to engineering design and operations, after analyzing the conditions derived from the previous simulation, we needed to design a mechanical ventilation and conditioning system in order to meet the comfort requirement for the hours, which our passive systems weren't adequate. Our main goal of our HVAC system was to reduce the total area of space which needed mechanical ventilation and cooling, and to maximize the natural ventilation hours. For the remaining hours, we incorporated a radiant floor cooling system coupled with a chilled water cooling system with fan coil units. Our total load of the building came out to be 460 TR for a total air conditioned area of 8,300 meters square. We also try to have separate control of our sensible and latent cooling to have a better control of our energy usage. Integrating our MEP systems by effectively laying out the main ductwork and the fan coil units in the corridors allow us to have higher headrooms in the classroom spaces and increase the spatial quality. We decided to incorporate radiant cooling coils in our flooring so that the cool air was in much closer proximity to the student working heights. Furthermore, integration of louvers as a design element along the courtyards helps us supplying cool courtyard air to the fan coil units in the false ceiling. Large spaces like multipurpose hall have underfloor air distribution systems for cooling and ventilation, as the stratification of the cool and the hot air would cool the regions occupied by humans more effectively. Finally, for maximizing our system energy usage, we incorporated certain strategies, namely night purge ventilation, which cool the mass of the building, sensible heat recovery via heat weight exchanger in our AHU units, precisely calibrating and having a precise operational schedule and having zone-specific controls, recapturing of water from the dehumidified air from the AHU and the condensed air from the fan coil unit, which was again used in cooling. Night cooling by operating the chillers in the early morning hours and storing the cold water in the cold water storage tanks and use it during the school hours allowed us to drastically reduce our energy consumption, which furthermore also allowed us to reduce our capital cost of our chillers, as we needed much smaller size chillers. Three structurally sensitive spaces needed a lot of thought, were the long span spaces of the cafeteria, multipurpose hall, and the swimming pool area. Since the multipurpose hall and had a play area above it, we had to ensure it withstand the resulting live load as well, for which we incorporated a grid slab. Another structural challenge was the space frame above the cafeteria, which supported our PV panels. To avoid buckling of our RCC columns, we used V-shaped steel columns, which also act as a part of our facade and add an aesthetic element. Lastly, the roof design over our swimming pool area in the basement is also specially addressed. Since the roof system is supporting a football field over top, flat truss typology is used there, for which the calculations were done according to the SP38 code to ensure material optimization and optimal structural stability. Finally, we brought together all the smart systems which were above discussed into one coherent system to keep a check on their energy usage and their operational schedules, for which we propose on having a building management system which connects all of them and have a control room in our basement. It would also operate the lift safety controls, smoke and fire detection systems, daylighting sensors, and the security cameras.
In the recent years, climate change and erratic weather patterns have made it a necessity to design a school which is resilient to threats such as flooding, fire, diseases, power/water outages, as well as making the building envelope durable and long lasting. Major causes of fire within school buildings range from faulty equipment, lab accidents, electrical overload, etc. In order to contain the fire, compartmentalizing and containing the fire through an efficient sprinkler system and smoke detector system, as well as wall assembly design, is essential. Teaching students through drills and explaining protocol that has to be followed in case of an emergency, using evacuation plans, fire exits, signages should be made part of the curriculum. Lying between Yamuna and the Hindon River, the site lies in a floodplain that gets mildly affected during monsoon. Through design and landscaping strategies such as bioswales, raising plinth level by 900 mm, drainage gutters, and screening to prevent debris collection and harvesting rainwater, we had tried to avoid waterlogging on the site. Infectious diseases spread very quickly between children in closed spaces. This is especially important in the light of COVID-19 pandemic. Using active technologies like the incorporation of UVGI and three-layered screening of the stay layer and maintaining 6.5 air changes per hour, and through passive protocols such as touchless technology, staggered bus timings can be helpful in reducing transmission of such diseases. It is important to prepare the school for disruptions and fluctuations in power/water supply by making the school energy/water independent. Through use of solar batteries, the school remains energy independent for up to 3 hours. Grid tie inverters ensure safety of workers sent to fix the system in case of power failure. Underground water tanks ensure that the school can provide for its water requirements for up to 5 days. A detailed cost evaluation of the building was done to make it affordable to the target market. The proposed capex is at 1,073.76 million rupees, which is 2.4% more than the base case. This increase in capex can be justified by the life cycle analysis of various systems that are involved in the building. Several design choices have helped us in reducing costs, reducing the cooling load of HVAC systems using passive design, solar PV panels, which give us up to 78.15% savings in 20 years, screed flooring using efficient fixtures, and BEE rated appliances further reduce the cost of the building. Noida is currently in the midst of a massive commercial and residential development and is expected to bring in a large number of expatriate families due to the commercial boom. We have conducted a thorough SWOT analysis, which studies the strengths, the weaknesses, threats, and opportunities of the site. From this analysis, we have inferred that the proximity of the school project to the existing and developing commercial areas and residential areas increases its market value. Since there is no other IB school in the vicinity, this also ensures a large market for the same. To capture the early market, we will propose to conclude the construction of the project as soon as the new residents begin to settle in. The school has been designed to comply to the highest IB standards in order to capture the target market.
The school would shape students to go and serve the society in future, and hence we too believe in lending our hand to the community and empowering it. So, we propose a business model to provide surplus energy generated at the school to the farmers in the vicinity to use it for agricultural purposes with aid of a local NGO. This would prove profitable to both parties as the farmers receive energy at a cheaper rate than what the grid provides, and the school would incur a greater profit by this rather than sending surplus energy back to the grid. As per the wishes of the client, we have done a GRIHA compliance checklist which tells us that a project complies with a 5-star GRIHA rating.
We would like to end our presentation with a humble note that we, as a team, recognize the need for sustainable design and building practices, not only because it is the right thing to do, but also because it is the smart thing to do. Our approach to sustainable design takes advantage of what is readily available and explores what is practically achievable through integration of proven green technology. This thinking has ensured that our building remains relevant and buildable in today's context. As participants, we are excited to take forward our learnings from this competition to our future projects and create a positive impact on the environment. Yeah.
Thank you, team. That was you have delivered a very good presentation. I'll open up the floor for the jury members now. Uh, so I'll ask Carl to go first.
Hi, good afternoon, Team Polymorph, and would like to congratulate you all on a very well put together presentation. Have a few comments which I had sent earlier as well. I'm not sure if you had a chance to look at it. And similar comment to your other colleagues as well. You all have planned a basement, and on top of that basement, you've planned many zones where you've planned activities and green and all of that. So what happens is your site is about 3.8 acres, and when you take a good chunk of it out for basement, that restricts you in many ways in terms of planting of good indigenous trees and many other things on top of the basement slab. And whether you've considered natural light and ventilation in that basement in any way, please have a think about it. The other small observation I had is your building footprint is actually quite large. It's almost 40% or 35 to 40% of the site, which poses the question on how much you need to really build and how much of the site you need to take up. So if you can just give me your ground coverage ratio and your usable to built area ratio. Besides that, I think very well together, well put together presentation. Yeah.
Yeah, I think Priyanshu, you can answer all those questions. Yeah.
Sure. So to answer your question regarding the ground coverage, our ground coverage is 29%. Yes, the building footprint looks larger because the entire building complex is spread is quite spread out. However, we have spaces like the courtyard and other spaces, other buffer zones, uh, which don't let us exceed the ground coverage. The next point was about the backfilling. So the soil that we take out for digging the basement would first backfill into the contour that we've created in the landscape for the landscaping near the swimming pool region, the elevated football field. Then some part of would go behind that football field to fill up the zone between uh, that elevated region and the southern boundary. Then a site has a height difference of 1.5 meters from north to south. So there we can use it to level the site. And lastly, we have an understanding with the client to use the backfill soil in a developed golf course. Other than that, the fertile soil and the top soil was obviously be conserved for planting purposes.
Thank you. Good answers. Thank you.
Thank you.
Harsh, would you like to go next?
Yes, thank you very much. I think Team Polymorph, I think it was a very well-knit presentation, and I think graphically also very clear. That was useful, and in fact, I believe some of the questions that I had posed to you may have been answered, in that. So that I felt was quite good. I believe you may have reacted to my question, so that's positive. I have a couple of you can say they are clarifications, right? So you can try to explain, how the building operates, because some of the slides were moving quite fast. I could not capture them. So my question here is that you mentioned that you are using natural ventilation, so a lot of the year, the classrooms are naturally ventilated. That's what I understood. And you're also using night purging, to basically lower the loads, right, during the day when the air conditioning is operating. So now my question here is, plus the air conditioning system is actually radiant, plus there is a fan coil unit, or a dehumidifying unit, right, which is kind of managing the radiant load. So now question here is, I'll ask you, and if somebody, one of you can explain it, that let's say it's a transition month, end of February in Delhi, Noida. So it's not too warm in the morning, but it's quite warm in the afternoon. So the building actually, so you're actually, what happens on that typical day? When does the natural ventilation operate, and when does the air conditioning actually switch on? So how is that mixed mode thing happening? Can you help me understand that? And second, connected question to that, once you answer that, and if you have a number, right, how much percentage naturally ventilated, how much air conditioned in terms of time, right, of the year, it will be very nice to know. Connected question is that I see that you worked out a radiant system in the floor, right? Yeah, so it's actually a very different approach that you've taken. Usually ceilings are worked out. Now my question is that on a July or August day, kids are moving in and out, right, and opening the doors with humid air from your courtyards coming in and condensing, right? I believe there's a risk. And why did you not choose the ceiling instead? Because you anyway have a false ceiling, right? If you had removed it and exposed the mask for night purge, I would have understood it, right? So there are these connected things, I hope some of them you can answer in your, the way you're thinking about the building.
Yeah. I think Supreme, you can take up all these questions.
Yeah, so about how we went about having a mixed mode combination of our in our classroom spaces was, we initially analyzed what all where all can we actually use natural ventilation depending on our outdoor conditions, and also we included the factor of using the ceiling fans where it would create sensible cooling, which was not actually accountable but could be experienced through which we learned through our experience. So through this, we had created a complex Excel sheet where we could formulate what all hours could be used exactly for our now natural ventilation along with the ceiling fans. And we had scheduled accordingly in our simulations that these many hours would not need mechanical ventilation as it's already being completed through our cross ventilation and passive strategies. So leaving that about the other cooling system, we try to have a control of our temperatures and humidity, relative humidity, have more control over it. So we had radiant and radiant, which would actually provide sensible cooling, and our water cool system, which would provide latent cooling. So we specifically studied the regions where we would just need the cooling of the temperatures, where our radiant cooling would be at peak, running at peak, and only when there will be need of maintaining the RH values, that's where our air pumps would, AHU units would run and control our humidity levels and our latent loads.
So, do you think there would be a possibility of actually condensation on the floor next to the doors, simply because your cooling unit could have actually cooled the room, but your humid air is actually coming in from your courtyards, right? Essentially. So that's my
when we try to, so about that, when we try to, so it's a common fact that radiant cooling has a condensation problems, which is a general known fact for that system. So we try to understand which would be the better stuff to do to have it in the ceilings or have it in our floor level. So we went for floor level because having actual surface cooler temperature would actually make you feel much colder, even though the air temperature is not exactly cooler around you. So this just made more sense to have cooler floors, which were much nearer to the working plane of the students than the ceilings. But weighing down the condensation factor, I think we are trying to maintain the condensation factor through adequate air changes, as the both propose the same amount of condensation problems in both our ceiling and the floor cooling.
Okay, I think I'll leave it for us to kind of, as you move forward, like explore this. It's a complex topic. I believe there's a bit more to it, right? You may eventually conclude that you want radiant on the ceiling because of the view factors, right? The human body needs to see the ceiling to really radiatively cool itself. But on a floor, essentially, there's a lot of furniture and so forth, right? So, however, I like the way you're thinking about it, and I'm sure more optimum solutions can be worked out. Uh, there was one point I think you wanted to the night purging, right? How are you doing that, and how are you cooling the building, right, with your ceiling and all not exposed?
So
So,
I'll just interrupt, just sum up the answers because I'll have to take one more question from Isaac at the end. So keep your answer short.
okay.
Go ahead.
In our in night purge cooling, what we try to do is have a yes, we did ceiling, fall ceiling, but we kind of accounted for that, and also could see the advantages of cooling the actual built mass of the walls and the structural systems, which would actually help us kickstart our cooling systems initially in the morning, which would not put sudden loads the occupant would actually move in.
And sir, I would like to add something if you would allow me to. Sir, mainly night purge also had this thing because sometimes when the windows are closed and all, the temperatures inside rise, and so, like essentially it kind of becomes a glass box, our building. So it's important to have some part during the night open because we know in night temperatures are lower, so that temperature could be equalized inside the spaces with the outside, that cooler temperature, so that for the morning the temperatures are cooled down. They are not holding the heat from the other day. And then sir, there was one more thing for the what happens if we have a chilled surface and we have humid air coming in, it would cause condensation. But as we saw from our simulation, the times when we have high humidity, which is of course the monsoon season, July, August, we actually don't need that much of sensible cooling. So actually our radiant cooling system is quite reduced that time, and even not working sometimes, because of which the surface won't be cooler, because most of the requirement is the latent load, not sensible load. So we could also check the dew point temperatures very very specifically with the graph. We didn't do that, but I think most of the time we would only require during the high humidity time, we would only require the latent load to be taken care of mainly.
Thank you. Isaac, any
Yeah.
concluding remarks from your end? Yeah.
Okay. So finally, I'm able to get it. A well-conceived approach, I think, and congratulations to the team for having taken some good steps and well-proven technologies. Um, I also found it very interesting that you visited the Indira Paryavaran Bhavan, right?
Yeah.
As a case study. Yeah. But then I think finally you ended up using a totally different kind of materials wise, if I say, than what was being used in the Indira Paryavaran Bhavan. Yeah. Uh, what did you learn from Indira Paryavaran Bhavan that you shouldn't do in your particular case?
Yeah. I think Hardik, you would like to take up this answer.
Yeah, there was one problem. Indra Paryavaran Bhavan had earth air tunnels incorporated, but after some time, because earth air tunnel have a recharge time, like first of all, you need certain climate conditions. It usually works better in dry climates, not in humid kind of climates, and then it also has a recharge time. You could only use it for certain time, and then you need to close it so that the earth could recharge, and that heat sink kind of quality, because the earth also takes the heat from the air due to the earth tunnels and heats up. So that we were thinking, but because of that study, we actually wanted to have much more control over the kind of air coming in. So we actually, that was I think one of the main things about our study from the Paryavaran, that we didn't use earth air tunnels and totally controlled our ventilation through mechanical means.
Thank
Okay,
you.
good. Yeah.
Adding to Do we have a
Sorry,
minute or so?
no. Sorry. The time is up.
Okay.
I had already exceeded 10 seconds for you, but we'll have to stop here. Thank you, team. You have done a great job. So this was the last presentation from the educational division. So the team, I'll request you to leave. Jury members, you can stay back for a while. Thank you,
Thank you.
team. Yeah. So, folks, that was end of the presentations from educational division. Our esteemed panel had shown such a dedication to assess these entries, and I want to thank all the jury members for taking out their time and for their thoughtful assessment and comments. And I would like to congratulate all the finalists who had presented their work today. Uh, As the jury coordinator of this division, I have had the opportunity to see these teams submit their work for the deliverable 3 and as deliverable 4, and they have done some incredible work. Let us not forget that these teams had discovered a way to collaborate and do integrated design while being physically away from each other for most part of the last 8 months. I think that itself deserves a round of applause from all of us. So well done, teams.
Absolutely.
This evening, the jury members will meet and decide the winners and runners-up teams. So, whom are we guessing out? So, who are we betting on? So, meanwhile, please make sure you have given your vote for the People's Choice Movie Award, and feel free to hang out around the auditorium and meet jury members and other guests in the networking zone in the lobby. All our finalists are invited to the internship fair. Please enter the fair through the lobby at uh, at 5:30 p.m. tomorrow. And see you all tomorrow at 10 a.m. for another exciting day to coming up. So I would like to thank all the jury members once again. And I'll be ending up this division for today. So thank you all the jury members.
Thank you, Gaurav. Are we connecting separately now?
Yes, I'm sending on you to the WhatsApp. Okay, thank you.
Thank you. Thank you.